Well, good afternoon, everybody. Welcome to our workshop today. Thank you for joining us so much. My name is Michelle Diaz. I'm the Education Program Manager at Trees Atlanta. And today's workshop, it will be about the neighborhood ecosystems. Well, good afternoon, everybody. Welcome to our workshop today. So Trees Atlanta mission is to protect and improve Atlanta's urban forests by planting, conserving, and education. We host a lot of events year-round. I invite you to join us. And today, our speakers will be Jason Gordon, Michael Thomas Cole, Elizabeth McCarthy, John Calabria, Kim Cutter, and James Leon Shelton. We're very excited to have all these professors for the University of Georgia, and we'll be learning along with them as well. During this workshop, you will have the opportunity to ask questions after each of the presentations. Please submit the questions through. They can also use the chat feature. And then at the end of all the presentations, there'll be additional time for Q&A. After this event, you will be receiving a survey email. Please provide your feedback on how can we improve your experience and how can we continue providing virtual education. To learn more about upcoming events, please visit treesatlanta.org and select the calendar option, and you'll see in there all of our volunteer projects and all of our education programs. Also, follow us on social media. So the first speaker today will be Dr. Kim Cutter. And he'll be coming up with his presentation in a minute.
It's good to see all of you. I hope everything is doing well with you. Notice that I have a pandemic beard, and we're going to talk about ecosystem connectivity, how things are connected. So let's talk about this. When everywhere you live, work, and play is part of a ecosystem. You may move in and out across boundaries, but in urban suburban areas, it's all about the connections that you have between the resources available and the organisms that are there. And so we do have a problem in urban suburban areas between green spaces that have ecologically viable volumes and organisms that power and support life, and hardscapes, which constrain and stress organisms and disrupt sometimes resources. So if you take a look downward, looking from the top down on a landscape, you got buildings, you've got pavements, sidewalks, parking lots. You've got a lot of hardscapes in and among a lot of greenscape. And hopefully you have more greenscape than hardscape. But remember that there are utilities, resource concentration utilities, infrastructures that connect all of these things. So we've got to be very careful when we're trying to calculate how much green space we have, that we remember there are above ground and below ground connections between all of our hardscapes. And there are connections between all of our greenscape islands, corridors. And these interconnections within an ecological framework are that we used to have when people lived a mile apart in the forest. All of those interconnections with our ecological framework have really been supplanted by artificial resource concentration and delivery systems. We use infrastructure and hardscapes to get water into our houses and out of our houses, energy into our houses. We've got all kinds of resources coming in and out, and our hardscapes, our infrastructure helps concentrate these resources so that we can use them and that we can live in urban suburban areas all together. And so as we concentrate and deliver these community resources for our survival, our life, unfortunately, the leftover space is usually what's dedicated to greenscapes. Leftover space is usually left for living things, where our concentration systems get us resources so we can live the quality of life we want. As one example, resource concentration for humans, as we concentrate energy, water, life forces for living together, living in our communities, living in a house, as we concentrate these resources, the ecological states and rates of change, those interconnections in the ecosystem decline. The more we concentrate resources for us to live, the fewer interconnections that we have. And it geometrically decreases. The more we concentrate, the more we push our resources into these hardscapes, infrastructures. We have become addicted to hardscape systems. And if we're going to live in urban suburban areas, we're going to have to be dependent upon these hardscape systems to carry much more load, human load and health. We're addicted to these hardscape systems, but it does separate us from the ecological support and the ecosystems that surround us. Now, one way to take a look at this connection process is what's called a textile model. Just think of it as a woven cloth. And of course, a woven cloth is only two-dimensional, where an ecosystem is four-dimensional. But everywhere lines cross in our textile, that's something. A tree, a fish, a bird, a butterfly. It is something. It's an item. And then the connections between those items, those are our ecological connections. What is provided one way or the other. And so we have many connections, many items. The best way to look at that then is here's our threads. The threads are connections. Wherever the threads crossed are things, objects, living things. So when we're taking a look at these type of connections, most threads are held together because of their interconnections. The threads are held tightly by their interconnections. And under stress, if you push or pull, twist on the cloth, both the connections and the things are stretched and pulled in one direction or another. But all the threads help provide strength to the ecosystem cloth. But then if we start to lose some of these things in our ecosystem, or we change some of the threads, some of the connections between the things, we start to degrade the ecosystem slightly. And as change occurs, and there's always going to be change, but if we lose too many things and too many connections, then when you pull and stretch on the cloth of the ecosystem, it's more than realignment. It's more than just reorganization. change can bring a loss of connections, a loss of connection points. Too much stress and strain on the ecosystem cloth can greatly degrade it. And so we get our cloth kind of having a bunch of holes in it. We don't have as many things as we did before, living things. We don't have quite the number of ecological interconnections that we used to have. And so there's some point that when you're looking at an urban-suburban ecosystem, when does a cloth of an ecosystem become just a few threads and a few things? Now, the next thing we need to talk about are major ecological problems in our community neighborhood ecosystems. The three major problems that we have in urban suburban areas are we're increasing hard surface areas, the hardscape, we're increasing that. We have a decline in the total ecologically active volume out there, and we have a lot of changes in past and current ecosystem functions and processes. Things are changing. They will continue to change. Sometimes it's negative, sometimes it's positive. But one of the things to keep in the back of your mind as we look at the interconnections within an ecosystem is a system, what's its maximum sustained use? In your neighborhood, in your block, in your area, what's the maximum sustained use that you get out of your neighborhood ecosystem? And that's usually, you can calculate this with math, and I'm sorry we have to have math here just after lunch, but the resources that come into the site, the resources that go out of the site, and the on-site generation of those resources, that helps set maximum sustained use. But the interconnections, the process changes between these resources, those are critical. And that tells you how much sustained use you can have in an ecosystem. So what are the resources? The resources that we have, the four primary ones, are energy coming and going and moving through, atmosphere going through that's filled with oxygen, carbon dioxide, and pollutants, things like ozone, and carrying water vapor, and then water itself moving through, going in transpiration, going in evaporation, and finally, the biological units on a site. That's your genetic resources. So if we talk about energy to begin with, energy management, remember that the sun is giving us a set amount of energy every second, every square foot, every day, and that's called a solar constant. And about 2% of the energy that's striking our plant surfaces are used in photosynthesis. Now, if we're going to manage that energy, we don't want to bake it into a desert. We want to screen the soil surface from direct energy fall. We want to screen the hardscapes because all they do is re-radiate and heat the air that goes over our ecosystem, advected heat that can just use a lot of water and damage our sites. We want to break up the energy impact over quite a large volume. And all of that will help us effectively use water for living things rather than for physical management of temperature. So one thing to think about is if the sun is hitting on the top of things with always the same amount of energy, if we have, say, mown turf grass out there, between the top of the turf grass and the bottom of the soil where the roots are limited to, that's a fairly thin area where all of this energy impacts. But if we can raise that energy impact, the primary energy impact level, if we can raise that 75 feet into the air, we're still having the same amount of energy impacting the top, but we have a tremendous ecologically viable volume in between energy impact and the bottom of the rooting system again. So we have a hard, abrupt impact that we could have. We could have a parking lot where the energy impacts within the very surface of the asphalt. Or we can have energy distributed across a very large volume. So when we have all of this energy from the sun coming in, it produces a lot of heat units in hardscapes. It's reflected back in our landscape. But if we have the same amount of energy in a greenscape, an evaporative environment, we can reduce heat load by quite a bit. Now, another thing we need to remember are the engines that power our ecosystem. We have dual ecological processors, and they're all temperature driven, temperature dependent. And this engine that most people see are the photosynthetic engine, the green stuff up high, that's powered by light, water, and nitrogen. We also have a detritus web engine. The detritus engine depends on carbon, water, and oxygen. And notice that both of them require water. Water is essential. So when we're looking at these engines, we have leaf arrays that's acting as an electron pump using water, light, and nitrogen. It's running at an ecological temperature that if it varies too much, we start to have stress and strain. And in the rhizosphere, the area around the roots and the roots, we have the detritus engine that's variable and very active. The top of the photosynthetic engine, the top of the tree is fairly passive. It's the root system that's active. So the bottom line is the photosynthetic engine fuels the detritus engine. The detritus engine fuels the photosynthetic engine. Last thing we need to talk about are the number of primary producers and consumers in our ecosystem. So if we have a light harvesting organism, like a tree, standing out there, it generates a huge amount of energy transformed from the sun. And then a consumer may eat a leaf, chew on a twig, and it will use that energy for its life, produce a little bit of heat that is wasted on the side, and another consumer will eat that consumer, and another consumer will eat that consumer, each generating a little bit of heat, using that energy for their life until we get back to the environmental average of what we have in the detritus food web. So another way of looking at it is light is coming in and a prime producer is making carbohydrate. And we're producing a little bit of heat as waste, and we're producing carbon as waste. And consumer after consumer uses some of this, and then the waste goes into the detritus system. And what we get is this, an ecological grid. An ecological grid that in the center has differing rates of exchange, different importance of organisms and how they influence the ecosystem. And all of this is very changeable. It's very nebulous. Day to day, season to season, year to year, this changes and morphs depending upon the resources coming in, going out, and generating, and the number of organisms you have there and the type of organisms you have. That's the ecological grid, the ecosystem grid that we live among. So what's our conclusions from all of this? You can take a big, deep breath, sigh of relief. We're not going to have any more ecological math. But our conclusions have to be urban forest ecosystems. It's always about the organisms, the states, and the rates of change, because it's always changing. And those things that change the most are resource quality and quantity, engine health, the two engines that drive this ecosystem, and the human impacts on it. And all of these things, you can do something about in your neighborhood. The other message or lesson that this can help us with is that life facilitates life. To have life, you need life. The more ecological surfaces and volumes you have, the more possibility for biodiversity that you have. So we've got to have the resources available. We've got to have these interconnections between living things and their resources and processes if we're going to have good biodiversity. And finally, the lesson all of this teaches us is that ecosystem active management is essential for community stability, sustainability, and livability. So we've got to do something. We can't sit by and let ecosystems become wound down, exhausted, losing organisms and losing interconnections. We have to do something to help manage it, to make sure that we are having a healthy and happy life in and among our neighborhood ecosystem. Are there questions, comments, or general complaints?
Thank you, Dr. Cutter, for introducing this workshop. I think it was a great way to just like introduce how we're about the other things we're going to be talking soon. I don't see any questions from the chat right now. Okay, so there's a question here. Where can one go to study this further?
The wonderful thing about this is that college, technical courses, extension service courses, master naturalists, master gardeners, master naturalist programs, any level that you want, there is available resources out there. And if you're really excited, you can go right to books that deal with ecosystem structure and health, and they can be at a child's level and they can be at a college classroom level. There's so much resource out there, and we are going to have so much more change coming with climate variability and how it will affect neighborhood ecosystems and trees. So there's a lot of material out there, but the best way that you could do it today is to go and take a walk. Go out among the trees and among these ecosystems in your neighborhood, walk around the block. And don't look at the hardscape, how everybody's house looks or cars look or pavement looks. Go and look at how the trees and greenscape looks.
Yeah, so we also had a question about if these presentations are going to be made available. And yeah, this recording will be posted on YouTube. Is there any other question for Dr. Cotter? So one person is asking, I live in an HOA and there is so much control on what one can do. guessing if you can provide some suggestions for this person.
There always is. And sometimes these agreements that and covenants that we have are really about how the aesthetics of the hardscapes look. And they leave out the ecological or ecosystem aesthetics. They leave out how our ecosystems function. And so we have to sometimes band together to make sure that we get what we want and what we need in our ecosystem functions. And it doesn't have to do with hardscape issues. It has to do with greenscape issues. We must be more active, proactive, and dare I say, we need to be militant about getting our greenscapes to be what we want them to be.
And a follow-up question from the question before, if UGA has any master naturalist program, if you're aware of.
Yes, and all you do is contact your local extension program, the University of Georgia Extension Program and extension agent, and they can set you up with a master naturalist program that can help you understand both the primary producers and the consumers in these ecosystems, in these the ecology of urban and suburban Georgia.
Well, thank you so much, Dr. Cotter.
Thank you.
There's compliments about your presentation and your beer in the chat. So thank you so much for your time. Somebody's asking, just to finalize, if you still teach.
I teach 3 classes. I teach tree identification and tree ecology, and I teach our new program of community forestry and arboriculture. I teach a course in technical arboriculture and applied tree biology. And we have this new program, and has just started. Jason Gordon is the head of it, and he can tell you more about it if you need to know more. But we're trying to, at the University of Georgia, help urban, suburban people manage their natural resources through this program.
Yeah, Dr. Gordon will be the next, and he could continue this conversation as well. So there's one more question for Dr. Cotter, and I think after this we'll move into Dr. Jason Gordon. And we were talking about the HOA and the neighborhoods and what can they do? And this person is asking if there's any examples or models of neighborhoods that are getting this right.
The problem with that question is the word right. There's no right or wrong. It's just that we can move the slide and gradient toward more greenscape, more ecologically literate work, or we can just pave over everything and have more hardscape. Most people, in the way they view their quality of life, want more greenscape. And so for every type of community, every type of situation, what is right for them is different. And so some communities that are mainly residential, they will have one view of what's right for them. If you have a lot of businesses, or if you have communities that have a lot of manufacturing, there will be a different level of right, how much green space to have. What we do know is that we are down about 20%. We should have 20% or more green space than we have right now. And we've got to try to move forward and try to find that space.
Thank you, Dr. Cotto. Well, and Dr. Cotto will stay around for a little bit as well if there's any more questions. Now, so Dr. Jason Gordon is going to be talking and addressing the tree canopy management.
Okay, hello everyone, good afternoon. Michelle, you see my presentation slide?
Yes.
Okay, wonderful. Well, thank you. Like Dr. Coder, I am with the Warnell School of Forestry and Natural Resources and also in the Community Forestry and Arboriculture program. It's good to be here with you today. I've been tasked with talking about planning the urban forest. So we're going down this road where Dr. Coder kind of explained this interconnectivity, and now we're taking the next step by thinking about kind of what kinds of considerations do we make in order to improve this interconnectivity. In 20 minutes, I'm basically going to be giving you kind of a 30,000 foot view of how to achieve this healthy urban ecosystem involving the dimensions that my colleagues will be addressing in greater detail later on in the workshop. So these are the four kind of topics that or themes that we'll be talking about here in this presentation. First of all, Dr. Coder, I don't know if he mentioned the word scale, but that's a lot of what he was talking about. And we really have to kind of emphasize this as part of our learning objectives with you today, that how important scale is. And I will be going back and forth between talking about the yardscape, what you can do in your yard, but also the community, which Dr. Coder talked extensively about, the neighborhood and the city that you live in, or the community that you live in, and everything in between. And so it's important, if you walk away from this with one really important thing, it's that scale matters, and that what you do in your yardscape makes a difference around you as well, both on the smaller scales, medium scales, and up to the large scale. Because we're talking about planning, we also have to talk about goals. What do we want in the first place, both at the individual level in your yard, but also kind of as a community, as a collective group, as a local society. We're going to be talking a little bit about resource assessment, because we can't do any of this without knowing what we have in the first place. So I just want to give you a brief idea of how a resource assessment occurs. What do we do, particularly about urban trees? And then I'll be talking a little bit about having a plan, what the urban forest plan is, and kind of a tool that you can use to have a plan, create a plan in your own landscape. So the next slide I have, not this one, but the next slide I have is a bit of a bummer. So I'm going to start off with this to start off with some good news. For years, I've been using Atlanta as kind of a poster child for urban tree canopy. Now, I know we got a big city, we've got our challenges, but institutions like Trees Atlanta and the city of Atlanta and others, some great urban foresters, great arborists in this city, we have an amazing tree canopy. This is why we are called the city in the forest. And Atlanta has 47.9% tree canopy, which is the most tree canopy in the United States for any city that has done a study like this that has assessed their tree canopy. That the highest percentage of overall tree canopy in the nation. Of that tree canopy, 61% is in single family residential land. That is our tree. 61% is single family residences. Think about how important that is. And so we cannot just be thinking about managing public trees. We have to be thinking about private trees and private properties as well, if we're going to address this issue that Dr. Coder was talking about ecological connectivity. So here's the bummer slide. These are some of the challenges that we're facing as a large city. You know, first of all, Dr. Coder talked a little bit about what is known as the urban heat island effect. Atlanta having a lot of impervious surface, a lot of hardscape, kind of keeps this bubble of heat above it. Whereas around in the surrounding areas, where we start to get more in the suburbs and exurbs and then rural areas, you have so much more vegetation and higher vegetation in terms of the tree canopy. And that allows that heat to dissipate. Whereas in Atlanta, we create this island of heat. And that's a major issue. And that contributes to climate change and to ozone problems and so forth. We also have disasters that we're thinking about more and more. You remember a few years ago when a tornado went through downtown Atlanta? I had a conference. I couldn't go to the conference because the the hotel, the building was destroyed then. Here's a picture of Atlanta dealing with the smoke from wildfires, I think up in the mountains at that time. And it looks like something you might see out west. Floods and storms obviously are a huge issue and becoming increasingly more important as we see changes happening with the climate. Water quality and storm water are big issues. We have soil, air, and water pollution that we have to be considering. Soil compaction, a huge issue in Atlanta, particularly as far as planting trees, our ability to have healthy trees. As that photo down on the lower left shows, we have congestion and noise, and we have to deal with invasive species. We have to deal with, as Dr. Cole is going to be talking about, wildlife conflict issues. I remember being here 20 years ago, and you never really heard much about wildlife in the city, but now we have deer problems, and we have all kinds of, you hear about black bear coming closer and closer into Atlanta. So these are things we have to think about that affect our environment, but also how our neighborhood ecosystem can mitigate the impacts of these challenges. And it's all very important to be thinking about, not address as single issues by themselves, but address it as a comprehensive whole. So it's critically important to consider scale when we talk about urban ecosystems and what you can do to help them. And how these, you see in this picture, how all these different kind of landscape features are interconnected, as Dr. Coder was talking about. Obviously, we have the yard scale first. To think about this, what can we do on our own property? How does our own property scale up? How do the effects scale up into the neighborhood scale, for example? Somebody asked about what are there kind of model places that are kind of tackling this. And I don't know if they're tackling this in kind of the ecological sense that we're talking about, but in a certain way they are. And we have a landscape architect who will be talking later, Dr. Calabria, who is an example of a landscape architect that is taking ecological considerations into practice. And here's an example of Reston, Virginia, which is a designed area, a designed community like Peachtree City. And you'll notice there that all of the homes, all of the cul-de-sacs have this green buffer around them. They're doing what Dr. Coder just described, which is increasing pervious surface, increasing the greenscape. And why are they doing that? I don't know if they thought about it in ecological terms like what we're talking about, but they're doing it because they knew that that improves local well-being. Residents want to have that. And then we have the city scale. So that we can effectively address those urban challenges I talked about, we got to be thinking about our own backyards, but also larger scales like the city, the entire city. We got to be asking ourselves, how do the actions I take in my yard benefit or harm my neighbors downstream? Now, both public and private property are key to Atlanta's sustainability and resilience. Remember, we have over 60% of Atlanta's trees are private. So private property is key. And this depends on improving the amount and quality of tree cover through management of critical tree attributes, such as diversity in age groupings, such as the diversity in species composition, and also maintaining healthy trees. You got to remember, it's not just about planting trees, it's about having healthy trees after you've planted those trees. So Dr. Coder mentioned the engines and all that, and inputs and outputs. Well, that's related to a concept called urban metabolism. And this is kind of this metaphor that describes the physical exchange processes of urban systems. Inflows like energy, water, people, and materials and information, if you look at the top part of this slide, those become outflows of waste, other people, and information. Now, since the Industrial Revolution, most cities have been operating on this kind of linear form of metabolism, which is really unsustainable. We produce too much waste. We become this kind of parasitic mass relative to the areas outside of the city. And this is especially true in the era of climate change. It's just not very sustainable. The consumption of energy, water, and materials in the city has a huge external impact on places downstream and downwind of that city. Now, trees play a critical role in recycling these waste materials, mitigating the urban heat island effect that I talked about before, reducing stormwater, and supplying other benefits that lead to a circular kind of metabolism, which is much more sustainable. So in short, trees are this massive engine of recycling. Planning is about taking actions to achieve specific goals. And so we have to plan at all of these scales to encourage improved ecological connections. The goals toward achieving a healthy neighborhood ecosystem might look like this: creating a safe and attractive environment, both in the city as well as your yardscape. Maintaining and enhancing urban forest cover. We often dictate that as we want to increase cover by 10%, for example, 5%, 20%. Maximizing the well-being of residents and visitors goes without saying. That's because this is related to well-being or to quality of life. But also minimizing hazards to life and property. Think about what happens to trees in storms. We have to maximize the benefits while reducing the risks that some trees cause, because they're organic, they're living organisms, and we have to take care of trees. Now, the final bullet there: improve coordination of management activities with other associations, neighborhoods, departments, and offices. Wow, that is showing us again that scale matters, and we have to move across different levels, across multiple scales of decision making. So those goals are kind of common goals. You'll see those goals oftentimes in an urban forest management plan. There's a number of things we can do to achieve these goals, and my colleagues will be talking in more detail about these activities later. But broadly speaking, we have engineering, what we call green engineering. This is applying green roofs and other green infrastructure, silva cells, rainwater capture, LEED building certification, which you might have heard of. All of these are engineering the environment so that we have better space. We see the silva cells there in the top right picture that help us to have better rooting systems for trees. Basically, it's improving this harsh urban environment that we live in. We can have better policy. We can have better regulations, maybe stricter development regulations and ordinances, better vegetation ordinances, tree preservation ordinances. We can require less impervious surface, and we can have better pollution restrictions, for example. We can have urban silviculture, which includes invasive species removal. All that kudzu, got to get rid of it, but we have other kinds of invasives as well we have to deal with. Oops. Urban silviculture you don't hear much about yet. It's an up and coming kind of thing. It's about growing trees. We talk about rural silviculture. Urban silviculture is growing these patches of trees, patches that Dr. Coder already mentioned. And it's about improving these patches of trees and the benefits that come out of it. So not just single trees here and there, but these patches and corridors of trees. And then we have landscape restoration, which Dr. Calabria is going to talk more about. This includes things like deculverting streams, but it could also be about prescribed fire on the landscape. You don't see a lot of that now. I think it's going to be increasing across the country. A few years ago, I was in Memphis, Tennessee, where they did that in the city of Memphis, just on the outskirts, in this large open space area that was public land. And they did that to improve the ecological situation there on that landscape. Prescribed burning in the city, it's pretty amazing. Making sure the urban forest is fully stocked, getting that 20% of stocking that we have to fill up is critical, that Dr. Coder talked about. That's critical to achieving our ecosystem goals. And very importantly, we have to make sure that tree species we select are planted in the right place, given our objectives for planting, the characteristics that we want for those trees, flowering or with a pretty bark, that kind of thing, shade, given the limitations in the soil quality and quantity of pH and other kinds of site conditions. Young tree early care is super important. A young tree should be healthy material, should have no girdling roots, no wounding. We should ideally have a central leader depending on the natural branching of that particular species. We got to remember to plant wide holes, not deep holes. We're not digging the tree to China. We got to make sure that that new little tree is happy and then backfill with that same soil. That starts off that tree so that it can then continue to produce benefits. And as the tree gets older and larger, it produces more and more benefits to our landscape at the yard level or the city level. And then also, while trees can be very resilient, they're biological organisms. So we can't just leave it alone and forget about it after planting. We have to be thinking about pruning that tree when it's young to develop a structure that'll be strong against storms. We have to regularly care for that tree and prune out damaged or codominant branches and look for decay to address hazardous situations as we move on. So you see, when we're talking about planning, we got to think about the short term, but also the long term. And we're talking about trees, that long term can be 100 years. Improving soils are one of the biggest issues we have in urban areas, particularly when we're talking about trees and greenscapes. Just planting trees helps protect the soils and protect water. But we need to really focus on our planning and our thinking about this on limiting and ameliorating compaction, preserving trees and construction areas when possible, when we know how to do it right, and increasing pervious surfaces. Pervious surfaces are where water can get down into the soil and into the system in that urban metabolism, to help that urban metabolism. We do that through filter strips and detention basins and other things that our upcoming speakers will be talking about. Dr. McCarty and Dr. Cole are going to be talking more about habitat. We got to be planning for and creating opportunities for communities of plants and animals to live in our yards and across our city. It's possible to manage habitat so that fewer conflicts occur between people and wildlife, like what we see a lot now in Atlanta, but also encourage desired wildlife to thrive. It's important that we live in this symbiosis, this relationship with wildlife that we have in our cities, and allow them to thrive in the right kind of healthy kind of way. Another thing about planning is managing spatial patterns. We can mitigate the impacts of urbanization by creating more connectivity between corridors like the Beltline and patches like parks. You know, each of our yards are small patches of green space and have this impact on water, wildlife, and ecosystem benefits, which then has a huge impact on urban metabolism. Now, at the city scale, we see the Beltline, Atlanta is doing this by connecting these various parks, like you see in this map, with the Beltline. Those parks are green patches, habitat, they're water reservoirs and so forth, and they're connected by that Beltline, which is a green corridor that allows movement between these places. And that's kind of the goal with that idea. So we are actually starting kind of practicing at a large scale some of this stuff that we're talking about today. But before we can plan and create goals, we need to know what we currently have. And this is called a resource assessment. Now, I am most familiar with an urban tree assessment. There's all kinds of assessments, whether you're talking about habitat, that involves an assessment. Whether you're talking about water resources, that's another kind of assessment. Most of my experience is with urban tree inventories. And we conduct these resource assessments so that we know what we have on the ground, so that we can plan and schedule maintenance and make management decisions. Assessments are part of a long-term monitoring and making adaptive decisions to new situations, like an influx of new residents or a 100-year flood. Again, like Dr. Coder said, it's really important that when we're talking about all this, that we embrace the changes that will occur, including destructive changes. We have to be able to be flexible and adapt to those. So assessments also give information on the value of ecosystem services that trees provide, and I'll show you that in a minute. The bottom line is that we can't manage what we don't have, and in order to optimize urban tree benefits and ecosystem benefits services, we have to have management. Here is an assessment of Atlanta. I believe this was back in 2008 as a collaboration between the city and Georgia Tech, the two primary leads on this project. And you can see how this is percent of tree canopy across the city. You can see how it's uneven across the city. It's also uneven between neighborhoods. And socioeconomics oftentimes plays a role in this as well. But this is just an example of what an assessment, what the final product might look like. And then the city can prioritize different areas in terms of planting and maintenance and management based on species distribution, based on planting space. This is something you all can get to. This is from a free software package called iTree. It's actually a suite of tools. iTree is an example of a top-down type of inventory in some cases. In other cases, it's a bottom-up inventory where people go out and in the field, they take measurements of trees. You can also do it top-down, which is using aerial photography. This is produced by the U.S. Forest Service. And these two things. On the left, you calculate tree benefits, the ecosystem benefits of trees in your yard. You can put your address in and it calculates the trees in your yard as an estimate. The one on the right is reporting ecosystem benefits based on what you might want to plant. And there's just, I think there's, I don't know, there's 10 to 15 other kinds of tools in this iTree suite. Very neat stuff. So having a plan is the first step towards a resilient neighborhood ecosystem. Cities will oftentimes have urban forest plans based on their tree assessment. Plans help determine if a sustainable urban forest is actually being achieved as you monitor and evaluate that plan, the actions of that plan. They may or may not involve private trees. Like I said, private trees are key. You know, if you want to address the urban forest, you have to get to the private trees. Oftentimes, city plans will just address street trees, which are right-of-way public trees or park trees and that kind of thing. But that's not really the urban forest, is it? Those are just public trees. All plans have similar components. They have a vision or some type of desired future condition. What do we want? This is why it's so important for an urban forest plan to engage the community, because we have to share this vision. It can't just be the urban forester that has this vision. It has to be residents as well. You also have a set of goals and objectives. You'll have an idea for how to involve stakeholders, whether through tree boards and whether through public forums. You have some kind of framework for resolving issues and conflicts regarding the urban trees, gathering and analyzing information. That is the urban forest assessment. You have an action plan. Those are the steps you take along with a timeline to reach your goals and objectives. And then you have monitoring, evaluation, and a feedback loop. And that feedback loop is what's key to that adaptive management aspect of the urban forest plan. Plans have to be adaptable to these future uncertainties. Remember what Dr. Coder said is that these ecological connections that fabric is constantly being pulled one way or another. So planning has to acknowledge that and really kind of embrace that, if you will. Individuals and residents can be engaged with this planning by advocating for urban trees and supporting the development and implementation of a plan. And an organization like Trees Atlanta is a great conduit for residents to become engaged with the urban trees in Atlanta. So lastly, that's all kind of on the city level or the community level, but what can you do in your own yard? Well, obviously you can hire a landscape architect, which when it comes down to the nuts and bolts, that's a good thing to do, and you take advantage of the knowledge and the skills that they have. But if you just want to play around, if you just want to kind of explore a little bit, there's this free software called Canvas that I recommend to people quite often. And it's very simple. It's a souped up version of Adobe Photoshop, but it's free. It was originally made by the National Oceanic and Atmospheric Administration to visualize sea level change. We have this publication at the Warnell website, and you can just go to the Warnell website and then search for Canvas. And let me just give you a few examples of this here. Very few examples here. This is the original picture of a yard. You can see there's kind of this sugarberry, I think is what that is there, that's not looking too good, that's in pretty bad shape and kind of old. And just to kind of give an idea, to explore a little bit what that might look like, within Canvas, you can create these trees, these new landscapes. We see some added shrubbery and some other trees there. And that gave the owner a little bit idea. So apply this to these ecological concepts we're talking about, and you can put in all kinds of things in order to make your yard more of an ecological representation. This is just an example for pruning to show you a little bit of diversity. This is a person that needed some limbs pruned off, and you see what happens. Gives them an idea of what it might look like. So final slide, takeaways here. From this, planning, management, and advocacy happen at multiple scales. We have to be thinking about that. What happens in our yard can be seen downstream, can be felt downstream. Trees have to be a part of the planning process because of the huge amount of benefits that trees provide. They're a core part of this urban ecosystem that we're talking about. We have to have good planning and management of urban ecosystems, and that will mitigate the challenges and changes that we will be facing more and more in the future. We have a number of professionals, we have extension agents, we have Trees Atlanta, landscape architects, arborists, and so forth that can help you and help your community with this. We also have some tools that are available, some free tools that are made for the public that the public should be taking more advantage of. And then the last thing, the last message we have is that you are an urban landscape manager and you can make a difference in the landscape. And I think that's really one of the main goals that Trees Atlanta is trying to get across as well, is that you can make a difference. So with that, I'll leave it there. Thank you, Michelle.
Thank you, Dr. Gordon. I think that was a great explanation, definitely. So we have one question before we move into Dr. Cole's presentation, and he'll be talking more about the wildlife habitat part of the ecosystem. So the question is there a program like iTree that is being worked that is more inclusive of other tree values, those that are not included in iTree?
Oh, other tree values.
Yeah. Overall, looking at even more tree benefits and putting a monetary value on them.
Well, iTree is obviously the go-to, and it's a free software that's been around for 20 or so years. So those tree values are kind of the core estimates. Now, there's other ways of valuing urban trees and urban forests, but they're not, and for example, one of those is called hedonic valuation, hedonic pricing, which is where you look at how property values change based on tree canopy. There's not necessarily, that I'm aware of, there's not a tool that is publicly available for something like that. We've actually tried to make one, and it's just been, there's a lot of challenges, a lot of technical challenges to that. Another way of valuation is through plant appraisal or tree appraisal. And there you have certified arborists who can do that kind of thing. And that's another kind of using different kinds of formulaic methods. That's another kind of valuation. But as far as something similar to the iTree software, that's pretty much it. There's a lot of inventory softwares, but as far as measuring those ecosystem services, as far as I know, iTree's been pretty much the go-to package.
Thank you. And we're also going to be answering questions at the end of the presentations. And just so you have an idea of how our agenda is going to go, right now, Dr. Cole is going to be doing a presentation on wildlife. Then we'll be taking a 5-minute break at around 1:20. Then Dr. Elizabeth and John and Jay, Dr. John and Dr. Jay are going to be presenting. So take it away.
All right, Michelle, are you guys seeing the right screen here?
Yes.
All right, perfect. All right, thanks, Michelle, and thanks, Jason and Kim, so far. So I'm going to talk about backyard wildlife, both how to create habitat for it, but also how to deal with some of the conflicts, some of the resources that might be available if you're having struggles with backyard wildlife. Some of this will overlap with what Dr. McCarty will cover after the break on more of the insects and pollinator side of things. I'll probably, if you have questions about that, it might be better to hold off. She'll definitely better suited to answer some of that anyway. So we'll get going there. Let's see. Okay. There we go. All right, so couple goals, I guess 4 goals for what I'm going to cover in the next 20 minutes or so. First is just understanding what wildlife habitat is. If we know what wildlife are looking for, we are best suited to either create more of it if you're interested in bringing certain critters to your backyard, or if there's other critters that you don't want in your yard, we can think about these different components of wildlife habitat to reduce them or eliminate them, thus excluding them from your backyard, eliminating some of the problems you might be having. Oh, excuse me. So once we know what pieces animals are looking for on the landscape, then we can talk about how do we go about the process of creating and establishing those components on the landscape. Now, that being said, anytime we talk about creating habitat, that means we're creating better conditions, which means we're basically growing more animals. We're increasing the density and abundance of those on the landscape in a given place and time. Now that might mean your neighbor's doing it, and so you're ending with more deer in your yard, or maybe you want to see the deer, but now there are too many deer for your vegetable garden. So we need to talk a little bit about the trade-off between wildlife habitat and the wildlife conflict. What do we do if we've basically made our yard too good for what we feel is acceptable in terms of the number of animals? And if we get to that point where we have too many animals or we're running into conflict, what do we do to address those issues? What are some resources that are available? All right. So I'll give you a second to read this. I like this comment and comic, and it fits very, very appropriately, I think, with what we're going to talk about today. So the reason I like this comic is that it really articulates a major change on the landscape that's really happened in about the last century here in the United States and globally. So if you went back to the 1920s or 40s or so, about 40% of the American population lived in urban areas. Today, that number is about 82% and growing. So we have a massive increase in the number of people that live in large urban centers. At the same time, particularly in say the last 20, 30 years, we've seen increasing interest in promoting environmentally friendly development practices, the increase in the number of greenscape, urban parks, golf courses, things like that. We know that there's mental health benefits and other physical benefits for having wildlife and wild things around you. And so we have this dynamic that's happening where we have more people that also are interested in having more wildlife and more wild places around them. What that means is that we are going to be dealing with more and more wildlife issues and interest in wildlife as we go forward. All right, so first of all, let's talk about what wildlife habitat is. So this is a great sign. It just kind of really points out the different components I would be interested in. So if you're talking about your backyard, city park, wherever we're talking about 4 fundamental pieces. So we're talking about water. So this might be a drinkable water source, like a pond like this, but other animals might receive most of their water source from the vegetation they eat, for example. We need sources of food. That could be stuff that's provided directly, like a bird seed. That could also be vegetation plants that are going to provide that same kind of resource. We need space. In large part, this could be talking about space for raising young, something like nesting cover, things like that, but there needs to be space there. And then shelter, some kind of cover, whether that to be for creating nests, nesting habitat, or for bedding or fawning areas if you're talking about deer or in around town. So we need the shelter. So these are the 4 pieces that we got to think about when we're building wildlife habitat. Now, when I talk about habitat, and Jason actually alluded to this already, we're not talking about it, or we need to talk about it and think about it in terms of the scales that are appropriate. So I've got a Google image here of Fernbank Museum, and I pulled that up because I'm guessing a lot of people that are watching this maybe have been to Fernbank or been around it at some point. And so you might be familiar at least with that general area. So, there's the golf course north of it. The Fernbank Forest is kind of the northeast there of the museum, and there's a big park down here, and then suburbs all the way around it. All right, so let's think about this area of Fernbank. So if you're thinking about bringing critters to your backyard, you need to first identify what critter you're interested in and determine whether or not you need to have all 4 components of that, or maybe just one component of that. So if we think about something like a worm or a tiny mouse or something, you probably need all 4 components in your backyard because that's all the bigger of the area that they're going to use. But if we talk about even like in this case, an eastern gray squirrel, this would be the average home range of an eastern gray squirrel in an urban environment. You can look at this quickly and see, okay, so the whole museum, a little bit of forest, a little bit of trees and stuff around it. That's a pretty big area. That's bigger than basically most people's backyards, right? So what we're talking about in this case then is that we need to have at least one of the components of those 4 in our yard if we want to attract them to our yard. because very likely they're going to get those other three or some of those other components somewhere else that are outside your yard. So that's the part you have to realize is depending on what you're trying to attract, you have to realize whether or not you're managing habitat at the appropriate scale for those animals. We can go even bigger. So here's white-tailed deer. So all of a sudden we're talking about they're using part of the golf course. They're using about a good chunk of the fern-bedding forest and some of the surrounding communities. If we get into carnivores, so here's raccoons. So even a bigger landscape, right? So now we're dealing with a pretty sizable part of the neighborhood, maybe an entire subdivision. And then if we think about something like an urban coyote, which this would be about the average of an urban coyote, not necessarily for Atlanta, but just in general across urban cities in the United States, you know, we're talking about a very, very large area. And so you may not be attracting coyotes to your neighborhood or your yard, but there's a good chance they could pass through it going from, say, one for food down the block to going to the park the other way to find shelter, right? And your house is in between, right? So when you think about these scales, you might be the movement corridor between some of these different resource components. So that's the first thing to think about is realizing what I want to manage for, and am I managing for it at the right scale? All right, so we kind of touched on this already. We want to think about who we're building habitat for, what animals. Is it birds, is it reptiles, deer, hummingbirds, or pollinators, things like that. Once you've identified that, there's kind of a core set of steps that you want to go through. And this is kind of a fuzzy image, I apologize. I grabbed this off the web from a different source. But the first step is figuring out, once you know who you want to manage for, you need to figure out what you're starting with. So make a plan. So in this case, you can see they drew out the house, the deck, the garage. They've drawn they've graphed out what they have currently to start with. So they've got a butterfly house, hummingbird feeder, some shrubs and stuff like that. So once you know what you have to work with, then you can start to decide am I missing things? Do I need a bird feeder? Do I need a bird house? Do I have certain plant species that aren't actually providing any benefit to the species I'm interested? Can I get rid of them and bring something else and put something else there? And once again, so we've got this plan in place. Now we need to figure out which pieces of these do we have. And if we're dealing with something really small, maybe we need all 4 pieces. All right. We built our plan, we thought about it. Now these are kind of, and I want to mention this tracks, I pulled most of this information from an extension publication from Mississippi State. It's a really good, great resource. There's other sources out there. Audubon Society has some of this, National Wildlife Federation. There's a lot of stuff out there that have kind of walked through the same process, but this is where I've pulled this info from. So first step is in building habitat is to think differently. Wildlife evolved with very different aesthetic values, if you will, than humans. They don't necessarily want a nicely green manicured lawn with nicely pruned shrubs and trees. A lot of them like the eyesores on the landscape, old trees, stumps, rocks, whatever. And so you need to think differently in how you approach your landscaping of your yard. Maybe you have to incorporate some of these things that aren't maybe as attractive. Now, of course, that comes with some caveats that maybe there's county restrictions or ordinances, HOA restrictions that don't allow this stuff. So you got to work within those bounds, but just be aware that you might want to be thinking differently about your yard. The other big thing is dumping the lawn. The recommendations are out there. If possible, you want to get your actual green manicured lawn to something like down to like less than 40% of your yard. This is what's going to provide a lot of vertical structure, like you can see here, but also diversity of plants, which means diversity of insects, diversity of food sources, things like that for a lot of different wildlife species. You want to talk about, if you have the opportunity to replace non-native species, go to native species. They're going to be much more in line with the species you're trying to attract. This is a book. I think this is put out by the State Botanical Garden, but there's lots of resources like this for the Southeast or for Georgia you could find on Amazon or wherever. And one highlight of going to a more native landscaping type backyard is that typically these species, because they're evolved in this system, are going to require less water and maintenance compared to those non-native species. So it's going to give you more time to enjoy your backyard. With the native landscaping, if you can, do as best you can to implement not just horizontal diversity, but vertical diversity, vertical layering. So you can see here different heights and complexity of species. So different species like maybe stuff like some of your backyard wildlife might really like really thick ground cover. Other ones are going to like, you know, a 4-foot tall shrub. Think about this because those are each providing unique components of that habitat for those species. Do everything you can to remove exotics and particularly invasive exotics. This is a document from the from UGA Center for Invasive Species. You can find it online, and it goes through a lot of problem invasive species in Georgia. These species probably destroy more natural habitat every year than development. All right, so if we can replace these with natives, we're doing really good, both for the ecosystem, but also our backyard wildlife. All right. I know this is going to be a touchy one, but at the end of the day, science tells us the best thing we can do outside of creating habitat is to manage our backyards and our parks and stuff with to prevent roaming of our pets. So we don't want our pets killing wildlife. We also don't want them harassing them. You don't want to scare away the animals you're trying to bring to your yard. Now, cats are particularly good hunters. They're thought to be the #1 predator of songbirds in the United States. And then dogs, they'll harass and kill small animals and other wildlife. So if you do whatever you can to avoid leaving the pet, particularly unsupervised outdoors, because this will push and scare a lot of those animals away that you're trying to bring to your yard. And then lastly, the more you can reduce your pesticides and chemicals in your landscape, that's the better for wildlife. Most of these wildlife, in terms of pesticides, rely on insects either directly or indirectly. They're either eating the bugs or they're eating the mice that eat the bugs or whatever, right? And so the more insects variety you have in your landscapes, the more diversity of wildlife you're going to have in your yard. Same thing with lawn fertilizers. Lawn fertilizers, for example, they lead to really high levels of nitrogen in the ground, the water supply, things like that. That can be bad for fish and wildlife and humans as well. So if possible, reduce those things. All right, so we went through the process of creating habitat and we're bringing all these animals to our yard, or our neighbor's done it and they have a lot of animals come in the yard. Now we have to think about what are we going to do if we get to the point of too many animals. So I just want to highlight that this is a map of Georgia. There's about 6.25 million people represented here. These are the 24 counties in Georgia that have at least 100,000 people. This is high density counties, if you will. 124 people on average per square mile. And 85% of people here are living in these urban areas, all right, throughout the state of Georgia. Oops, wrong direction. That being said, even in these even these urban counties, these high population counties, there's big chunks of the counties that are actually still rural. So, for example, southwestern Fulton County is actually very, very, very rural compared to like downtown Atlanta, right? And by rural, I mean there's a lot of habitat. And Jason alluded to it already and mentioned it. You know, Atlanta's something like has the most tree canopy cover of any large city in the United States. That's a proxy, but at the end of the day, what that means is there's actually probably a lot of good habitat. That means we've got a lot of people with habitat, not only currently, but also as we're talking about trying to increase and improve habitat. Together with that, inevitably leads to is conflict. How do we deal with the social conflicts between people and wildlife, or people and people? To give you some perspective on what that looks like here in Georgia. So this is data from the newest program from Georgia Department of Natural Resources. This is the Urban Wildlife Program. It focuses on 9 urban counties for Metro Atlanta. If you're not familiar with them, check them out. They're doing some really phenomenal things. And so this is just data over all of 2020 for the calls they get by species. So you can see deer are their #1 reason for getting calls. And then after that, it's a 3 straight predators on the landscape. And it's hard to say what those calls necessarily are for, but maybe that's just you saw them and you're not comfortable with a coyote, for example, or raccoons get in your garbage, whatever. Now, they do also, with all these calls, break down, you know, what are these conflicts? What kind of conflict are they? A lot of these are in, you know, sick or injured animal. Maybe you saw a baby fawn or something got hit by a car, things like that. But what I'm really interested in here is this 2%, this property damage. So there's 2% of 2,000 calls. I mean, that's a sizable number of calls that have to do with animals leading to property damage. All right. If we look nationally on what urban wildlife damage looks like, it's largely being driven by raccoons, coyotes. Deer are a big one because of landscaping, beavers for damming up things like that. All right. If we look just in Georgia, and this is data collected from sampled from county agents across the state, and you can see in the gray bars is the urban and suburban areas, the number of complaints received over a year about wildlife damage. The vast majority of calls in urban areas relate to yards, gardens, and damage to their house. And you can see yard landscaping damage in the urban areas is the #1 cause. And so you've been talking about largely probably deer, armadillos, things like that. And so what are those animals then? So armadillos, #1, I think, no, let's see, armadillos #2, armadillos 3, deer are 2, squirrels are #1, rodents, woodpeckers. These are the 5 most commonly reported species that cause damage in urban landscapes. So how could you control that? You have to think about if you're bringing, like I said, if you're creating habitat for wildlife and you're building vegetable gardens, or you're building pollinator gardens where there's going to be a lot of bugs and insects, you're going to be bringing armadillos. They're going to root up and dig around in your yard and really and can cause a lot of landscaping damage, for example. Same thing, you have a nice vegetable garden, you're bringing deer, they're going to be eating all of your flowering ornamentals and things like that. All right, so you've got these problems, what do you do? There's some really great resources out there. I'm going to point out 2 of them really for the most part. So the first one is you can go to Georgia DNR's website. They've just revamped a lot of this. So here's the new link. And what they have is these are kind of the common, and not all these are completely updated yet, but they've been slowly updating over the last year. But you can go to this and click on, maybe I'm having problems with deer, for example. And they've got these really nice short papers on what, usually front and back at the most, of what are some of the conflicts, what are some issues you might be really concerned about, what to do in certain cases. So there's some really good information like that. Alternatively, you can go to our Warnell Outreach website and look at our publications for more extensive documentation. So a lot of these ones are, say, 3, 4, 5, 6 pages long, and they'll give a lot more detail on maybe exactly like the natural history of it, the biology of reproduction, as well as management actions. So in this case, maybe you're having your issues with armadillos now, and they're getting into your flower garden. So you can learn all about armadillos, and then there'll be a section in all of these documents that talk about how would I potentially reduce the problem? How would I either remove the animals? Who could I contact to remove them? Or what different things can I do? All right, so those resources are all available. If you don't feel comfortable or don't feel like you have the skill set to handle some of these things, you can contract with private companies. So you can go to the DNR's website and you can click on this button when you get there. It says find nuisance wildlife control operators. And if I click on that button, it'll pull up a Google map. In this case, I zoomed in and I clicked on DeKalb County. And when you click in there, it'll give you a list of all these different companies that are licensed went through the licensing process for Georgia DNR to be licensed animal control operators. And so they could come out and you have an armadillo issue, they could trap your armadillo and they will take care of the problem and remove it from your yard. If you're just interested or you're having particular conflicts or you want to know about, what could I do to reduce deer numbers overall in my entire HOA or something like any kind of issues, depending on the types of the questions, you can't find it on these resources. You can contact the Urban Wildlife Program. Their email's there. These are the 9 counties they currently operate in. By and large, I think you can think about drawing a circle around that really. So it's not like they won't operate in Western Walton County, for example. But you got the email and the phone number there for that information. And I know Kim also mentioned this quickly. The last one, University of Georgia. We have our Master Naturalist program. You can talk to the local county agents, or there's Mike Menjak, who is oversees that on the Warnell side of it. And then a new program that is just up and running is called Georgia Green Landscape. This is building green landscaping. It's specific recommendations to Georgia. Here's the site you could click on, you could go to, and they have all these different YouTube videos of how you would do go through each of these processes to, you know, put more native plants in or protect my water quality, what have you. So with that, I'm happy to take some questions. My contact information is there, phone, email. If you want to follow me on social media, whatever, we post things regular or whatever. So with that, I'll let Michelle ask any questions if any are there. So.
Sure, thank you. So one question here is, what do you think about the mosquito control companies?
I will not be suited. Elizabeth might be better suited to answer that, actually. I don't know enough about that subject to probably touch on.
Sure. So we can leave this question here pending for her when she does her presentation after the break. Another question was, how do I prevent squirrels and voles from digging up and eating my tulip bulbs?
So this goes back to those 4 components, right? The easiest way to get rid of an animal that you have a problem with is to figure out why they are in your yard, and either get rid of the resource or make it so that it is unattractive relative to the amount of benefits they get from it. You know, tulips, high nutrition, they want to eat it. So you've either got to figure out how to make your yard unlikable to squirrels, or plant something else. There's not an easy solution for this. This is squirrels, same thing with squirrels on bird feeders and stuff like that. There's not necessarily a great solution for it, other than you either are going to have to learn to live with it, or the easiest thing would be not to plant tulips, which I know isn't exactly an ideal answer, but that's kind of what you're left with.
And then the last question before we go on the break, it's if you could provide the reference for the Mississippi State Extension article.
Yeah, I will put that in the chat when I go find it again. So.
Yeah, thank you. All right, so we're going to take a few minutes break, and we should be back at 1:25. And then Dr. Elizabeth McCarthy will be presenting on how to manage your backyard for insect habitat. Stay tuned. Dr. McCarty, you can go ahead and start when you're ready.
All right. Good afternoon. Thank you so much for being on this presentation. This is one of my favorite things to talk about. So I'm a forest entomologist, and a lot of times I talk about dead trees and invasive insects, but it's so great to be able to talk about positive things that we can do to promote habitat in our own spaces. And note that I use the word messy gardening. This really pairs nicely with Dr. Cole's talk. We actually have not seen each other's presentations, but there are a lot of parallels. And so that very pristine, overly clean landscape, let's kind of step back and give ourselves excuse to maybe be a little bit lazy with our yards. And then we're doing it for the benefit of habitat, which is like a double benefit. All right, so the presentation goals, we will learn about the different kinds of insects in our own backyards, understand the habitat needs of insects, and learn how to enhance insect habitat in an urban setting or suburban setting. There's an icky factor with insects that some people have, and hopefully this talk will just open our eyes to the wonderful diversity and know that we're just scratching the surface. So first of all, what happens in a forest? And this parallels some things that were mentioned earlier, but there's carbon dioxide being converted to oxygen, there's growing plant material, decomposition, bringing up water. And so a lot of different processes are happening. And at every step in here, we could just throw insects all over this picture. They are a part of decomposition. They're all enmeshed in it, and it's all connected. So let's think about, I've got a picture here of a semi-forested area. So this is something that we could find out in the woods, but also maybe on a vacant lot or possibly the back portion of our larger lot that we don't pay that much attention to. And think about all of the resources that are visible in this picture. Now, I'm not suggesting that you make your front yard look like this, but just for concept. All right, well, there are a lot of different types of insects in that picture, in that setting. There are herbivores that eat plants. Detritivores eat dead organic material. Predators eat other organisms. Parasites live in or on other organisms, and they're part of that system. And then we hear a lot about pollinators right now. I mean, this is the hot topic, and pollinators are great. And I talk about pollinators all the time, but not to knock pollinators, but they are just a piece of this entire system. And we hear about pollinators being beneficial insects, but in fact, these are all beneficial insects. They're all a part of the puzzle, and we need all of them to be there. But if we want to keep pollinator focused, which I don't really want to do that for this talk, when you make pollinator spaces, all of these other players get to come along for the ride. So making those more complex habitats, a pollinator garden instead of a lawn or instead of a portion of lawn is going to benefit all of these players. And that's a wonderful thing. Now, we typically think about maybe a suburban area, urban area having a lawn. It's a lot of grass, and I'm going to beat that same kill your grass drum. You don't have to do it all in one day or all at one time or all of it. You can work it in phases. So for example, I moved 5 years ago into a lot that was 3/4 of an acre. And bit by bit, I've added pollinator spaces. I'm slowly converting to more native, not all native, but more native plants over time. This year, I sprayed with herbicide about 1/3 of my front yard and made pine straw beds. And eventually I'll put native plants in it, but it doesn't all have to happen in one day or be overwhelming and challenging. And whatever positive steps we make, those are great positive steps to make. And then when we provide that structure, we now have insects functioning in multiple layers of the forest system. There are insects up in the tree canopy. They're living on the tree trunks, in the shrub layer, the herbaceous layer, and that's the one we normally think about the most, but on the forest floor and those pine straw and mulch beds, that provides habitat, and even down into the streams. So look at all the insects that are there. Some of them are beneficial. They're all beneficial. Some of them, like the bark beetle, we think of as a pest, but bark beetles are actually decomposers. They are part of breaking down a dead tree. And when it's one tree in isolation, that's just a natural part of the process. Sometimes it happens in a way that can be problematic, just like with the wildlife. Something can be good in one instance and be problematic in another. But all of these insects are part of the native ecosystem. And so, for example, and I'll just fly through a few different insects, beetles. They can be pollinators, herbivores, detritivores, and predators. This one group of insects can serve so many different functions in the system. Flies can actually be all of them: pollinators, herbivores, detritivores, predators, and parasites. They are in so many functions in our system, and most of the time we really don't pay attention to them unless they're a housefly or mosquito. We can get so focused on negative perception of insects that we just are not always mindful of all the beneficials. So that would bring it back to what Dr. Coder said about the best thing that you can do, to make beginning steps is to take a walk and look at the green spaces. And so this pairs really well with that. If we can go outside and look at the native insects that are there and see whose habitat we're wanting to enhance, it really opens our eyes to the entire setting and positive changes that we can make. Wasps, pollinators, herbivores, predators, as well as parasites. And this is a sawfly. Who knew that such a crazy looking wasp was out there? This is another sawfly larva. It's a hollyhock sawfly. And I used to just let them eat my hollyhocks because they were so fun to look at. Now, here's a paper wasp. These are not very desirable. And so you may say, well, all wasps are bad. Well, no, it depends. If the wasp nest is on your child's playset, then that is bad. If there's a wasp that is pollinating flowers in your garden, then it's probably not going to bother anybody. So just understanding the context and when it's beneficial to remove these things from a setting and when they're actually providing important services. Herbivores, they're detritivores, predators, and herbivores as well. These are true bugs. So this is a spittlebug. This is a sycamore lace bug, which can be considered a pest, but really is not going to harm the tree. And this is a plant hopper. This is a picture I took when I was getting my master's degree. This is an insect that is native to the US. And who would have thought that we have this crazy guy hanging around? He looks like something you'd see in the middle of a rainforest. All right, and then butterflies and moths that are both herbivores and pollinators. And when we want a butterfly, we also need the caterpillar stage. And that means that we have to have habitat and food for that caterpillar. So if a butterfly is acceptable, but a caterpillar munching on some of our plants isn't acceptable, and so we remove the caterpillar from the equation, do you see that those are two goals that really are not meshing together? And I put a saddleback picture here because it goes back to that some things are beneficial and some things can be caused problematic. So if you make caterpillar space, it could be that you get a woolly bear or some other type of stinging caterpillar. Chances are, if it's out there in the yard and you're not messing with it, your chances of having a negative experience are pretty low. So try to understand risk and the benefits, and just keep that reality in your mind that our risks are very low and the benefits are very high, and then be careful where we need to. And then lastly, native bees. I'm not mentioning honeybees. Honeybees are pollinators as well, but they are not native to the US. They're more of an agricultural commodity. So it's more important, I think, to focus on native bees. There are 3,500 species or more of native bees in the United States. Most of them are solitary. They don't live in groups. And when we start worrying about ecosystem health, they are much better indicators than honeybees. So if we worry about pollinators, if we want to do good things for them, keep that focus on native bees. They are incredibly important. But pollinators, and I say that because that's been the focus of a lot of outreach and a lot of public concern, they do face increasing challenges. But remember, other insects do as well. If something's not good for pollinator habitat, it's not going to be good for other insects. So for example, there's habitat loss. This all used to be forest or meadows or wetlands. And now we have all of this here. And this is a degraded habitat. However, we can do positive things in that habitat that can bring lift to the entire system. There are less native plants. Most insects are specialists, and so they're not going to specialize on a plant that is not a native. They'll specialize on something they co-evolved with. For pollinators, there's a lot of parasite and disease pressure, and then unintended consequences of pesticide misuse. Now, I work with pesticides. I'm not anti-pesticide, but a tool is only as good as we use it correctly. And so before using a pesticide, think, do I actually have to use a pesticide in this setting? Is it necessary? Just because there's a bug eating a plant doesn't necessarily mean that it's a bug that needs to be sprayed. And then if you do use a pesticide, you have to read the label. That is a legal document, and that provides the safety fence to use that pesticide appropriately. But think about our forest habitat and a very typical urban suburban habitat. And so there's a roof, there's a driveway, there's grass, and maybe a few sad little boxwoods in the front. And that's pretty typical of newer development. But what if we take that very pristine and somewhat sterile space, and we're intentional about how we manage that space? It's okay to be a little bit messy with our yards and our spaces. What if we gave it all of these other habitat attributes that could be very easily done and can be attractively done, that provided the space and the resources for our native insect communities? And if we provide native insects, then we provide that food, that base of the food chain for things like birds. If you like birds, then learn to love caterpillars because they desperately need them. Caterpillars are a wonderful nutrition source for birds. So the four basic needs: nectar and forage or food, and some of this is a little more pollinator centric, but the same things apply. Moisture and salts, shelter and space. So for instance, pollen is made out of protein and lipids, and nectar is sugars. And so those two different four resources provide different things for pollinators. And this is nectar and forage, but food, it applies year round. We need year round resources, not just something that is blooming or active one time of the year, but think about providing resources year round for beneficial insects. You've got to have food for caterpillars. If you want butterflies, learn to love the caterpillars, provide food sources for them, and then be able to tolerate some of that damage. Well, how does that work? You don't want the plants right on your front step getting all munched up. Okay, that's fine. Plant something right up by your front porch that you don't want to get munched on by caterpillars. And have an area further away where it's acceptable to have some of that damage. My pollinator forage plants are on the sides of my house primarily, so they're a little bit more out of view. And then have diverse sources, so lots of different kinds of plants. And a word about natives versus non-natives and invasives. Native is better, but sometimes it's not always possible to have all native. I don't have all native. I'm changing my ratio over time. Non-native is better than nothing, and invasive, I would urge people to just completely stay away from invasive plants. There's very little good that's going to come from that. Moisture and salt, just like us, they need something to drink. Things get thirsty. So even small dishes of water, small bird feeders, change them out regularly, because if we leave stagnant water, then we get mosquito issues, and then that's problematic. Shelter. Okay, lots of different kind of shelter, and shelter is very much lacking in a lot of our spaces. So pithy stems on plants, when you're cutting your plants back in the spring, just cut them about 1 foot or 1.5 feet instead of all the way down to the ground. The plant will grow up around it. You won't even notice it. And those pithy stems, that's places where cavity nesting organisms can live. Log piles. Log piles may seem undesirable, or rock piles. Well, can you hide it somewhere? There's a big shrub layer between my house and my neighbor's house in the very back. A log pile back there goes completely unseen. Nobody even knows that it's there. Fallen leaves. I know that my trees are going to be very grateful that I have killed the grass and put mulch and straw beds around them. there's less of the grass that wasn't doing a lot of good. I'm not going to be driving the mower as close to the roots and damaging them. So I think, not feet and feet high, but that leafy habitat, instead of getting rid of all of that organic material, pile it up around the trees, and it makes your mowing easier. And then it provides habitat, for example, for this lightning bug. That's a baby lightning bug. If we like lightning bugs, then we need to have places for their immature to grow. We don't just want the one piece of the life cycle, but that entire life cycle. We've got to have substrate for all of it. And then space, dry soil for ground nesting bees, open flat surfaces for sunning. And, that little patch of yard that you have put mulch on, you've put sod on over and over, and you just can't grow grass there. Well, forgive yourself for it and move on. That's now your habitat for ground nesting and soil nesting bees. And hopefully they'll come and colonize it. So it is actually providing some good. And then you can lower that frustration level and know that it is a purpose that it is serving. There are lots of different native plants. I'll show a few different trees, but very attractive trees. In urban settings, quite often what we see is that a lot of the trees are native, and then less of the shrubs are native, and then less of the herbaceous plants are native. Being mindful and slowly making changes maybe takes one step at a time, but you can definitely be a part of providing that lift and that solution, and it definitely increases our enjoyment of outdoor spaces. So lots of really attractive native things that we can add to our yard. And then some places to go to get additional information. A team of us, there's a native plants and beneficial insects extension team at the University of Georgia. We're working towards some of these efforts. Lots of this kind of work is going on. There's information on managing your turfgrass pest insects, but still protecting pollinators, how to create pollinator nesting boxes. And this one on the bottom right is a really good one. It is selecting trees and shrubs as resources for pollinators. So additional resources, and I can put some of these in the chat once I'm no longer sharing my screen when John Calabria is giving his presentation. But there is an extension page for protecting pollinators with lots of information. The Center for Urban Ag has a list of resources under building your own pollinator garden. Becky Griffin is now hosting the Great Georgia Pollinator podcast. There's also a Great Georgia Pollinator Census that is a wonderful activity that occurs in August. And then the State Botanical Garden is a really good resource. They have a very active conservation program. And so Connect to Protect is actually a certification for pollinator gardens. And if you look at the requirements for that certification and follow that, that's a really nice first step to providing good habitat. And again, if we're providing the habitat for pollinators, we're making the habitat for lots of other things as well. A group of us are working with the Georgia Pollinator Plants of the Year. So it's a multi-agency team. And we pick plants that are conducive to pollinator habitat, and we're working with green industry to get those in the garden centers where they're easy to purchase. There's also a Georgia Native Plant Initiative with the Botanical Garden, and there is a list of native plant nurseries. So it's easy to talk about native plants, but some people feel like their hands are a little bit tied because, where do you get them? If you're in Atlanta, there are some native plant nurseries that are a little more accessible. I'm down in Tifton, and so that can be a little bit more difficult to access. But there is a list of native plant nurseries, and some of the plants that are offered in the big box nurseries are native. So part of it is just to look through and find out what is easily accessible that is actually a native plant. So I'll leave this with a screen showing some of the positive things that we can include in our yard for pollinators, how we can be a part of the solution. And hopefully this puts a lot of very small and large achievable goals in your hands as you begin to be mindful of these issues and take the next steps. And so I'll be glad to take any questions.
Thank you, Dr. McCarty. I know during these times that we've spent so much time at home, everybody's looking into like what new plants I can add and how can I attract pollinators. So I agree. I think that's a bit of a trendy conversation right now. Yeah, so it's a very positive thing.
And I've been doing this since I was probably 16, but not realizing this. So I'm very grateful that I'm working in a capacity that lets me articulate these things and be more intentional about it.
Yes. So there's a few questions here for you. The first one that came when Dr. Cole was doing his presentation, but maybe he mentioned maybe you could be a better, you could answer this better. The question is, what do you think about mosquito control companies?
I think that the best thing that we can do for mosquito control is to minimize larval habitat. That means control sources of standing water. I know that some people do like to get their yards sprayed and they feel like that is helpful to them. Nobody wants to be stung by or bitten by mosquitoes, and that is very understandable. It depends on what they're spraying. If it's a broad spectrum insecticide, then whatever they spray it on would kill anything. If they're just spraying BT, that is a more targeted insecticide that is BTI, actually, that is specific for larval mosquitoes. So it really depends on what method is being chosen. I can say that personally, I would not spray a broad spectrum insecticide all over my own yard. That's my personal choice. And I would encourage people to minimize larval habitat. And then if you're going to move next to a swamp or a wetland, then that might be a situation where it's not really reasonable to expect that entire wetland system to change because you moved there. And then maybe do things like mosquito spray on your personal self when you go outside. And that might be a bit more of a reasonable action to mitigate mosquito bites.
Okay, very good. Another question, what do you think of the, and I might mispronounce this word, neonicotinoids? Yes. The what do you think about that pesticide that is sold at the big box stores and some nurseries?
Oh, okie dokie. That is a whole ball of stuff. And I have actually worked on non-target neonicotinoid assessments in forests for about 10 years. Like I said, a tool is only as good as you use it well. Neonicotinoids are a broad spectrum insecticide class. They were developed in response to public concern about the vertebrate toxicity of older classes of insecticides. So part of it is that we know the word neonicotinoid and we have negative connotations in our heads whenever there are things like carbamates and organophosphates that have been around longer that do have higher vertebrate toxicity and are still toxic to insects. We just don't know those words. There's a label. Labels are used for safe application of pesticides. Some of the big bee kills that we've heard of have occurred because people apply pesticides off label. I know in my setting, in forest settings, neonics are used to protect hemlock trees, which conserve entire ecosystems with very little non-target impacts. So we have to be balanced. Most of the time in a setting, you're not going to have to use a pesticide. If you have multiple plants in your yard, multiple species, you're not going to have to. When we start planting things in high density, like in a nursery setting, then those are very susceptible for insect damage. And so nursery suppliers are going to have to put some on those plants for insect control so that it is alive and viable by the time it gets to you. So expecting a nursery to not use any pesticides is not going to be reasonable. So some research, neonics are persistent. Yes, they can get in flowers. So I'm not anti-neonics on plants. Part of it is good management. And I know that one thing that's happening right now is they're studying residual time of neonics in these nursery plants and then having longer times between treating them and when they can be sold. So if you want to plant a plant and it's had neonics on it in the nursery setting, put it in your yard, it'll grow out of it. And you know, it's not going to be an issue. Maybe shortly after you plant it, it could be a problem. If you're that worried about it, throw like some kind of protective netting on it. but I wouldn't not put a good pollinator plant out there because there was some neonic use in the nursery. Again, it's all about understanding risk, not really blowing risk out of proportion. And anytime we use a pesticide inappropriately, we could have negative impacts. But I would definitely use a neonic in some spaces before I would use other classes of insecticides. So I hope that answered the question, and my email is there. If whoever asked the question has further concerns, you're welcome to contact me and we can speak more in depth about this. I've been working with insect control with neonics as well as considering non-target effects for about 9 years. And so it is definitely a conversation and not a one-line answer.
Thank you. So let's move on now into Dr. J's presentation.
All right, I'm going to stop my share for just a minute and pull his up and then reshare. Okay. All right, can y'all see that?
Yes.
All right, I'll hit play and just speak up if you're not hearing it well.
Hello, my name is Jay Shelton. I'm a fisheries biologist by training. I work in the Warnell School of Forestry and Natural Resources at UGA. The title of my talk today, Fish Need Trees, Watershed Protection and Planning, relates to some things that I've learned over the years about managing fish populations and also managing watersheds, actively managing watersheds. So I, as I said, work in Warnell and I teach. I work with students quite a bit on a variety of natural resources issues. I talk a lot about fish, of course, and I talk about water quality as it relates to fish and other users of that resource. And I do a lot of sampling of fish, but also sampling of various aspects of environmental quality, water quality. That's the teaching side of things. And then I also have an outreach appointment. So I work with private landowners and a whole lot of other stakeholders who manage natural resources in Georgia, and manage water resources in Georgia. And that includes managing ponds and other impoundments from small to large impoundments. They're a very important resource, a valuable resource in Georgia. I do work a lot in the evaluation or the feasibility with respect to the ponds that exist in Georgia, many of which are very old and in need of renovation. But pond construction is not something that is common as it once was, say 40 or 50 years ago, partially because there are a lot of laws and a lot of agencies that are involved in the regulation of the construction of ponds, including the Corps of Engineers and the NRCS, and also state and local natural resource and environmental protection agencies. I also work in fish passage as an aspect of fisheries, the ability for fish and other parts of the aquatic environment to freely move. That's something that we now call aquatic connectivity. And I'll tell you just a couple minutes to tell you about some of those types of projects. They include projects that involve the removal of obsolete structures that affect aquatic connectivity, like dams. You know, in Georgia, we have a lot of very old obsolete dams that are no longer serving any purpose. They're no longer generating electricity. They're no longer involved in flood control. They're old. There are safety issues related to their age and the structure. And so we recently published a handbook, a guide to the removal or modification of obsolete dams in Georgia, which you can get more information about at the webpage that our aquatic connectivity team has. I'll talk about that in just a second. In all natural resources management, including water resources, there are a lot of stakeholders. There are a lot of people who have an interest because there are so many people that use that resource. And in state of Georgia, for example, some of those stakeholders that we work with include EPA, the Fish and Wildlife Service, as I mentioned, NRCS, the Corps of Engineers, the Georgia Department of Natural Resources, Wildlife Resources Division, which is where fisheries is housed. Believe it or not, when you talk about structures like dams or other structures that are over 50 years old, the Historic Preservation Office is also involved there. One of the major stakeholders in water quality in the state of Georgia is our DNR Environmental Protection Division, but there are also NGOs like the Nature Conservancy. There are river keepers organizations and even local municipalities. So lots of people interested in water as a resource, because our water resources are both diverse and very valuable. And by water resources, we're talking about flowing streams, permanently flowing streams, intermittently flowing streams, even small ditches and canals that oftentimes were made by humans, public lakes and reservoirs, wetlands, estuaries, coastal waters. All of these things are critical water resources, and they're all connected. When it comes to the quality, to our ability to utilize these resources, we tend to designate specific uses for the various water resources that I just mentioned, including things like drinking water and recreational use and fishing. Of course, there are wild and scenic rivers in Georgia, and coastal fishing. Those are all official designated uses of water. And so if we take that into account, we think about, well, what is the condition of the water resources, nationwide, as well as here in Georgia? Recent reports,
Dr. McCarty,
basically, it's not that great.
Could
because
you-
we find that
could you hide
rivers
that tub?
Their designated use.
Zoom bar? Yeah. I'm sorry. Yeah, could you hide that bar? Yes.
Oh, there we go. Thank you.
The floated, sure.
Don't support healthy aquatic communities. With respect to what we call the biological condition of our waters, and I'll talk more about how we get this kind of information. But this report indicated that 46% of our nation's rivers and streams are in poor biological condition, 25 in fair condition, 28 in good condition. Examples of this kind of information include the types of aquatic organisms that live in the stream, that include things like habitat, which we'll talk about quite a bit here in just a minute. And of course, these types of impairments can lead to the failure of the resource to provide to meet the designated use. So we've talked about water quality. What does that exactly mean? How do we use that term? Well, by definition, water quality refers to the physical, chemical, and biological attributes that affect the suitability of water for its use, whether that be agriculture or industry or drinking water, fish, recreation, trees, whatever. So that's the technical definition of water quality. We also look at other aspects of habitat, including a habitat assessment. In other words, what is the actual condition of the natural constituents of the home or environment for a particular organism, whether that be a fish or a aquatic bird or a turtle. And then this third area, which I'll spend a little bit of time exploring, is what we call biological assessment. So we talk a lot about water quality. Well, how do we know if it's good or if it's bad? Well, frequently we do that based on a biological assessment or an evaluation of the condition of a water body that is conducted by sampling species of interest that spend all or part of their life in that water body. And so that's where fish and other aquatic organisms come in. Biological assessments tell us what we know about a water body's condition. How do we know if it's polluted? How do we know if it's impaired? And two big areas that I'll talk about today, areas that we work in a lot, involve what are called fish biological assessments and benthic macroinvertebrate biological assessments. And sometimes we do both, sometimes we do one or the other. When I say benthic macroinvertebrates, that simply means the aquatic organisms, insects and other forms of aquatic life that live on the bottom of a stream. And so some of us might think of those as interesting ecological specimens. Others of us might think of those as, well, as fish bait, quite frankly. When we talk about biological assessment that involves fish, that is frequently conducted by a mechanism called an IBI, an Index of Biotic Integrity, where we basically look at an entire community of fish and we determine whether all of the representative groups are present or whether some of the things that should be there are absent. And we try to figure out why that might be. And that would include pollution sensitive organisms like the ones shown here, as well as pollution tolerant organisms, and a good diversity, a good mixture of all of those things. So some of those pollution sensitive fishes, like the ones that are shown here, we don't see a lot because we don't fish for them. We don't even necessarily know that they're present in stream unless you're a fish nerd like me, in which case you not only look for them, but you try to figure out what important role they play in the overall diversity and the overall ecological health of that stream. We sometimes think of these as indicator species because some of these species are pollution, since they're sensitive to pollution, they will be the first ones to disappear. We sample fish in a number of different ways in order to assess this community level information. And that is a good bit of what we do, especially in wadable streams where we can get in and sample these organisms. And then we look at this fish biological assessment specifically based on geography. We look at what we call different ecoregions of the state of Georgia. So we do not compare apples to oranges. We would make comparisons of streams that are within one of these ecoregions, like within the Piedmont, or we would compare coastal plain streams or streams up in the mountains. We don't look at big streams and compare them to little streams. We have to look at them based on their drainage basin or their watershed size. And we compare these to what are called regional reference conditions. Basically, we sample, and we look for the best possible conditions that exist in a particular area for a particular size of stream, and we make comparisons to that. And we give these streams a score, and they can score in different categories in terms of whether they are impaired or how severely they are impaired. Same approach applies with respect to benthic macroinvertebrates. We do a similar assessment. We stick to the ecoregion approach. We don't compare apples and oranges. We compare small streams and don't compare big to small streams. We still use this reference stream approach. Again, just like with fish, we know that some of these groups of organisms are more sensitive to pollution and some are more tolerant of pollution. And so what kind of factors can affect these scores? What kind of things can result, for example, in a poor benthic macroinvertebrate score or in a poor fish score? Well, there are lots of them. Some are much more common in Georgia. They include, of course, erosion and sediment issues. They even include the human produced and released pharmaceuticals, nutrients. They include some of the pesticides that we apply both on land and in water because we have oftentimes, if not properly applied, we can see off-target or off-site impacts from pesticide application. We have a lot of problems and a lot of fish kills in some cases that are associated with low dissolved oxygen conditions, a real problem especially in urban areas. And then another real problem in urban areas is what we call hydrologic change. In other words, when we do things to the landscape, to the watershed, to the land cover, like changing from forests to fields and from fields to impervious surfaces like rooftops and parking lots, those result in hydrologic changes that we know have a negative impact on these scores. I'll talk more about that in a second. What we tend to focus on are the perennial streams where there is a well-defined channel, where we have flow during essentially all of the year, and where aquatic organisms are present all of the year, so that we can kind of get some idea of how stable those types of streams are. But we have to remember that those permanent streams are connected to many smaller intermittent streams. they may still have a well-defined channel, but they tend to have periods when they flow in a wet season and periods when they don't flow. But these areas are very vulnerable to what we do on the landscape. They're very, very vulnerable to soil erosion and transport issues. And for that reason, we have to be very cognizant of our effects on these on the areas adjacent to intermittent streams. Well, to boil all that down, the bottom line is that any time that we create bare soil, in all honesty, anytime we do land disturbing activities, we have the potential to create problems on the landscape that manifest themselves in terms of streams, because everything flows downhill, basically. And so to show you how we can understand those relationships and what we can do with that data, there are 4 figures here, and they are relationships between the fish population, the fish community, those IBI scores that I just talked about, and a few different specific characteristics. So let's just take these in 2 different pieces here. The first one talks about subcatchment riparian forest, which is kind of a fancy term, but basically all that means is that riparian, so the area directly adjacent to streams, how much of the total area is covered by trees. So, you know, I talked about fish need trees. And so that those riparian areas, those trees that are adjacent to streams are very important. And what does that relationship tell us? That the more trees, the more of the area adjacent to the stream is covered by trees, the better the IBI scores. We see these IBI scores are going up as the amount of riparian forest land cover goes up. So really what that means is fish need trees. Now look at this relationship where it talks about the riparian cropland cover. So as cropland adjacent to streams increases, what happens to those IBI scores? They go down. So fish need trees, they don't need pastures. That's the bottom line there. Now that's adjacent to the stream, but let's talk again about the entire watershed, the entire drainage basin. If we look at the entire catchment area, not just the area close to the stream, but the area that drains into the stream, the entire area that drains into the stream, we see a similar relationship. At the subcatchment forested land use, as land use goes up watershed wide of forest, the IBI scores go up. Same relationship applies here. You see that as crop cover goes up in the watershed, not just close to the stream, but in the watershed in general, the IBI scores go down. Once again, fish need trees, fish don't need cropland. All right, so how do we apply all this stuff? Well, one of the ways that we can apply all this stuff is in the area of trying to come up with ways to restore streams where we have seen impacts. For example, when we see these impaired areas, what can we do to restore those streams? And part of that answer is fish need trees. So we can try to do the things that would allow for the sustainable regeneration of forest cover, both adjacent to the stream in that riparian zone and throughout the entire watershed, because we know that we see positive effects from both. As an example, you know, many of our streams, this is one particular restoration project that Dr. Calabria and Dr. McCarty and I are currently working on over in Gwinnett County on a small tributary to the Chattahoochee River called Crayfish Creek. We know that many of our channels have been drastically altered historically and by current activities, current land use activities, current development, big issues with urban streams. And one of the things we have a goal to do is to try to restore some of the natural sinuosity to streams. And then after we've done that, to try to restore that natural, fully functional riparian forest corridor along those streams. Another way that we can try to understand these relationships and try to make some good informed decisions is to look at the big picture. And when we, I mentioned the term watershed, so that a specific area that drains down to a particular point. So in this figure, you'll see 1, 2, 3 watersheds. So for each of these watersheds, this is land use information that tells us what areas are developed, what areas are forested, what areas are pasture land. And we can basically look both at the watershed and at these riparian corridors, these forested corridors, We can use it to kind of prioritize where we might want to focus some of our efforts. What other information can we use? Well, we can also look at things like the amount of sewer and other types of infrastructure, sewer and road infrastructure, things like culverts, which also can have an impact. Well, we can put all this stuff together and we can prioritize it based on everything that we've talked about so far in such a way that we select the points, the locations that are probably going to be of the highest priority. In other words, if we can make things better here, we can help the stream at large. And so you'll see the highest priority areas in this figure are represented in red here. And so we know that those are areas that we would want to focus on. We can add in things like sewer lines and roads and look for specific areas. We can put those two pieces of information together and look for specific target areas where we think we have an opportunity to do restoration. And one of the interesting things that would show you when we do that, we can actually do a lot of that without ever even going to the site and look at that information. And if we try to go down and look at those high priority sites, frequently this is what we see. So does this even look like a stream? Well, no, not really. It looks like, well, you remember I said that fish need trees, and if this is a stream, these fish don't have very many streams. On one side, they've essentially mowed right up to the edge of this stream. I'll show you now what the stream looks like, and it doesn't look very good. And it's not a very big surprise that when we forget about or we ignore this relationship where fish need streams of what the outcome is. And so this is what we find when we try to do these prioritizations. And so how do we put all this stuff together? Because we've talked today about, you know, a lot of different aspects of ecology, really. And I've kind of wrap it up by talking about everything flows downhill and where everything ends up and what kind of effects we see at the bottom end of these systems. And so as an effort to put all this together, try and tie everything we've talked about together today, the way I put it to students a lot is that everything is connected and nothing stays where we put it. So all of our activities in these four spheres are related to one another. So we can talk about atmospheric activities and things that are volatilized or deposited from our atmosphere. We can talk about the lithosphere. You know, we can talk about soil, and we can talk about the things that are adsorbed to soil, the things that are released from soil, the things that move through soil. We can talk about the living portion of soil and the living portion of our terrestrial ecosystems. And then, of course, we've got the hydrosphere, the focus for what I've been talking about so far, the water resources, the things that move into and out of those water resources. But one of the critical things is that all of those spheres impact and are connected with the biosphere. And got to remember, we are a part of the biosphere and we have a huge impact on the biosphere, but we also care about these other types of organisms and their relative well-being. In other words, if we are sustainably managing the entire landscape, then they are in good condition, and they are also indicators when things are not in good shape and can help to inform us about how to make things better. So hopefully this has helped you to try to put the big picture together here and to make sense out of all these topics. And I thank you for your time.
Well, definitely thank you to Dr. Shelton, who he couldn't be present in this event, in this webinar, but he made sure to record himself and send that to us. If you have any question, the speakers can also answer those questions for you. If there's no questions about this topic, we can go ahead and get Dr. Calabria presentation on water resources as well.
Great, thank you. Dr. McCarty, you could stop sharing. I might be able to jump back on with mine. Excellent. Well, my name is John Calabria, and hopefully you can see a screen with a forest on it and a stream?
Yes.
Excellent. Okay. I'm blind when I'm in PowerPoint world. So in any case, thanks for allowing me to be here. My name is John Calabria. I'm a licensed landscape architect in Georgia and the Carolinas, and have been walking the natural resource side for a while in landscape architecture. And had a couple of observations that I wanted to share with you that lead into design and managing your forested property. So the title is It's All Downhill, Enjoying and Stewarding Water Resources. And some of the things that I mentioned that I would share today are trying to understand some of the impacts to water quality. So rounding out some of the things that you have heard already, and then share with you a couple of ways that people appreciate the research on visual preferences of landscapes. That is, we take care of what we think looks good. So sometimes we have to shift a little bit of what we think looks good, and then look at some possible treatment options to ameliorate some of the non-point pollution that you've been hearing about. And I've been studying this for a while and know what not to do as well as some things to do on it, but very interested in what people's perceptions are, again, with the idea that people will steward what they appreciate. So here's a nice stream. You can imagine yourself transported to the mountains if you're not there already. Here's a stream that shows how we can enjoy nature, shows nice, clear, cool water, not very eroded slopes, lots of vegetation. The bugs and other critters are very excited to be in this environment. We may not all be able to attain a backyard that looks quite like this, but it definitely has the ingredients for things we'd like to see, particularly in the Southeast, with trees and canopy vegetation, understory vegetation, ground plane vegetation, all contributing good things to the stream and keeping it nice and cool. Well, that's not always the case. We have some impacts to water quality. You just heard from Dr. Shelton and some others about some of these impacts. And that's what happens when we change the land surface and build our buildings, build our parking lots, drain all our water away as fast as possible. So that puts a lot of bad things into the water. And keep in mind, this is water that we're all drinking from. There's water that comes from wells, but a lot of our water in Georgia is supplied by surface systems and surface intakes, either from lakes and rivers. So we want to try to dial back some of these impacts to water quality, and I wanted to share some of those things with you. But first, I want to discuss some of the things that are in the water that may not be at a level that we'd appreciate. So we've talked a little bit about nutrients and sediments. There's also different pathogens. Scoop your poop campaigns are important for that reasons. There's all sorts of other contaminants that come in, and then pollution that comes in. Plastic pollution is getting a lot of attention, a lot of impacts. And then don't forget about thermal stress. That's very important for some of our cold water fisheries, is to try to minimize some of the thermal stress. That is, it rains, water flows across a rooftop or parking lot, picks up a lot of heat, and then is discharged directly into a stream and warming it. So there's a couple of ways to think about these impacts to water quality. We often think about these forested systems as being our pre-development hydrology. Much of the Southeast was covered, at least the streams, in forested area. So here on the upper left-hand part of the graphic, you can see that if we have a system that has natural vegetation, we have about half of the water that hits on it goes into infiltration in our natural ground cover situations. And then about 10% runs off. But when we twist and tweak and adjust our surfaces, then we get something like the bottom right, where we totally change this water budget, and we do not have that pre-development hydrology. So instead of half of the water going into the ground and infiltrating, we have half of the water running off the site and very little infiltration. And then I'll just mention that some of the infiltration that we're seeing in the city or some of these urban areas might not be the infiltration that we want. It's not this nice runoff. It could be sanitary sewer systems and storm sewer systems that are not completely sealed. So there could be some infiltration of some additional constituents that we would not want to see. So what are some things that we can observe? So here's a typical construction site. Some silt fence and hay bales didn't seem to do the trick. You can have some erosion happening where that's where the particle detaches from the earth by the force of the raindrop, and then it runs off carrying that sediment, and then that goes into the stream and clogs up little spaces that critters need. There's other types of pollution that runs off, but that's one of the ones that we can see and is very visible. Some of the other stuff we can't see, but we definitely need to be concerned about that. Also to be concerned about is climate change. We're having more intense rainstorms, and it's actually blowing out some of our infrastructure. So these are some more reasons to think about what we could do to avoid this excessive erosion and sedimentation. There is a tourism angle. This could be a new tourist attraction. Here's our new Grand Canyon forming on one of the sites that Dr. Shelton, Dr. McCarty worked on that we were discussing. But here you can see on the right-hand side is the culvert that's supposed to be working to drain some area, and water has bypassed the culvert and then started creating some erosion. And this is problematic for all the critters like the wild trout that are trying to spawn in nice, clean, clear gravels just downstream of this area. So these are all reasons why we want to try to minimize some of these impacts. And if you want to think about it in a different way, there's ways to think about impervious cover as one way to understand how that might impact some of our stream quality. So here's a simplified impervious cover model, and there's other models out there for sure. But basically this suggests that even if you have very little impervious cover, you still may not have the best quality in your stream. But one thing that is certain, as you start approaching thresholds of 20–25% of impervious cover, that you definitely push your stream system into fair status or good status barely. And that's quite a problem, because we want to try to keep streams in good or excellent shape as much as we can. Then you could imagine the more imperviousness that you have that's not treated, then you definitely have some issues where your stream is all but poor no matter what you do. So what are some ways that we can try to reverse some of these trends? So we can think about things in visual preference. So there's a nice foundational article that came out in 1995 that I'll point you towards. Joan Nassauer crafted messy ecosystems and orderly frames. So she was trying to solve that riddle of how could we as humans try to appreciate some of these more wildland areas or some of these more messy ecosystems and embrace those, or at the very least tolerate some of those. So she has some ideas on showing that there's cues to care. So that might be some of the things that you see on the right-hand part of your slide, where you might, instead of having a large mown lawn area, actually have a very small and still usable, functional mown lawn or a little lawn verge, and then have some kind of structure like a fence or something like that, and then have your ecosystem kind of behind that. So that way you have more surface area devoted to an ecosystem than you would, say, just a big swath of lawn that may not be, may not have the diversity and abundance of species that we would prefer to see, particularly if we're interested in pollinators and other species. There's a couple other tips and tricks she offers for planting design and neatness, but the idea is to have those show that we are stewarding something in our conventional aesthetics, but then also allow our new ecological aesthetic to embrace some of the more natural areas that are behind that. So her 95 article is on the left, and then last year she was able to go in and kind of look at some of the state of the research, and you can see that a lot of people have tried to jump onto this, and I think in practice it works pretty nicely. Another theory to depart from some of the applied stuff is thinking about how people contextualize their preferences. So the Kaplans, or a husband-wife team that put together this theory and talked about different components in the landscape. And if these components registered in a certain way with people, then that contributed to them preferring or appreciating this landscape. So they simply suggest that mystery, complexity, legibility, and coherence are what tends to enhance preference when it comes to the visual preference of the landscape by the observer. So the coherence could be how well the scene kind of hangs together. Does it have some notion of being organized? The legibility is, could you see yourself moving through that landscape and getting back to where you came from? And it applies to visually. It doesn't have to mean that you locomote through it. You just are able to visually appreciate and see through that, and it becomes legible. And then there's a balance of complexity, which is how much is going on, how many different things are in the scene. And if you have too much complexity, then humans may not like it. If you have too little complexity, humans may not like that either. So there's a sweet spot. And then, of course, mystery. How does that scene invite you to walk deeper into it or not? And then back to the other components, could you find yourself back? So these are some of the more foundational things in preference, and some things that are coming out more recently are the idea of seasonality. So how might we appreciate landscapes in different portions of the season? As you can tell here on the study my student is working on, is basically if we looked at a variety of different stormwater control measures, they look very different across the year. So whether it's in the fall, winter, spring, summer, late summer, these have very different characteristics. So we are focused on green infrastructure and stormwater control measures, but trying to appreciate some of the seasonality, because some people might say, well, the plant bloomed through, now I want to take it down, but not realize that there's some additional foraging and nesting habitat that are beneficial if we were to leave some of those things up. And then planting design and some other things shape how we might appreciate and think about those. So as far as stormwater control measures and treatment options to try to improve some of the water quality or runoff of water quality are actually starting with planning. So in the Southeast, we have a lot of developed area. We have a nice network of streams. We have quite a high stream density compared to some other places, but those usually have a forested area and are protected depending on where the land is to basically have trees over the stream, which is a good thing. And these become corridors for a variety of organisms, as well as have some other ecological functions. So we want to try to do some planning so we're not all working in a vacuum, but actually working to contributing to an overall plan that I think you heard about earlier in the panel today. So one thing you could do is a suitability analysis, try to take different layers that are important and lay those over top of each other and see where those aggregate into areas of high concern to preserve or to go in and do some restoration. So here a student abstracted some of this. This is the UGA campus. Forgot to mention there's something about football that happens here, and then this is Lake Herrick, just to orient you. But had a student kind of look at from a connectivity standpoint. We've got the cemetery across the river. We've got the river itself. We've got some tributaries that are in varying states of function. And then how do we overlay our cultural landscape with that? We need our streets and roads and buildings, but how can we think about overlaying those to minimize some of the impacts to these areas so we can promote the connectivity and have our corridor ecology be as strong as it can? So one thing we think about is creating opportunities for these linkages, and then these linkages need to connect to something, and we call those hubs. And the idea with the hubs are that a lot of organisms can do all their different life cycling in these hubs, but then also be connected through these corridors. And that way we can start to approach some of our goals with how this might have looked like from a pre-development standpoint, particularly in regard to nutrient and hydrologic cycles. So out of this grew a green infrastructure plan for the University of Georgia in the Nature and Sustainability Studio that I've taught and co-taught in the years past. But here the idea comes about where we can have our different clusters of development, how we can still have our green space and have those come through campus, and then what are these hybrid landscapes. So once you have this plan, whether it's a watershed plan or a green infrastructure plan or stormwater plan, any of these things in place, and have that watershed assessment to direct where these efforts should be made, then you can start implementing and restoring, preserving, rehabilitating all those different things. So that's when we get down to the fun side, and that's taking all the things you learned about at the landscape scale and boiling down to the site scale, which I presume is what you're most interested in. So at the site scale, it's how do we go about creating these opportunities to link these hubs or patches and corridors together. And when we do that, do it successfully, we can have what's called a mosaic. It's a combination of all these things that's the most beneficial for a variety of our goals. And there's a lot of research on how to best do that. But again, this is just more to get you to think about taking the landscape scale, boiling it down to the site scale so that you can see that all these things are connected and try not to work on individual sites in a vacuum. So one part that came out of our site planning was to think about how to reconnect streams. Some of our streams on campus, as yours, might be armored channels. They have what we call rip wrap and run away because it looks so ugly, but it might be rip wrap, it might be some kind of concrete, something like that. But what are some ways to think about opening those channels up so we can plant the vegetation, the trees, and some other things, have the recreational opportunities, and also benefit some of the what I call bugs and bunnies that you've heard about as well. So there's ways to control runoff, which I'll discuss here in a second. But then once you've controlled the runoff, then there's also ways to improve some of the stream and fluvial geomorphologists can help you with this. But the idea is to create the stream habitat that'll sustain some of the organisms that we want to see that you heard about earlier in this panel. So what does this look like on the landscape? Well, let me share a couple of case studies with you. Would you believe that there's a stream in there? So the first part of a project is to go in and figure out what you have. Here you can see we have one of every single aggressive exotic in this area, and had to be able to locate the stream. So that brought up an interesting question, because when we finally found the stream, the research question became, why so much dye? Well, we were actually trying to pour dye into an area. This is a different project, but try to pour dye into an area to actually understand the complexity of the urban system. Where the water was going and where we thought it was going was two different places. But I thought you would appreciate the answer with St. Patrick's Day coming up, that the stream actually was dyed green. So that may not be the best thing, but at least we were able to find the stream and do a proper assessment and understand where water is going. So here's the project with the kudzu and other exotics. There was a channel, much like the one in the previous slide, that came down through here, of course, covered in kudzu, couldn't even see it. So this project had multiple partners to come in and create opportunities to create little areas for water to cascade across some step pools and have a nice aesthetic component, as well as make the water visible again, have a bridge that connects across this little pocket park, and try to create the kind of bones of a site where we could have tree plantings and other plantings, as well as some wetland plantings, to try to help improve the habitat as well as the water quality. So here you can see the picture in snow showing these discrete pools and then the walkway that goes over it. This is the before condition with the walkway. You can see some of the aggressive exotics, some other things. Those were cleared out. Did a lot of earthwork to try to reassemble some of these patterns that have been eroded by the stream and stormwater, and create an opportunity where we had these cascading pools. You can get up on the bridge, you can look down and see open water, which is a huge preference for people when it comes to that. Also being elevated above things and looking down is another visual preference that's really important. Having access to the water is important. So here you can see there's some actual structures that we built. So the local middle school had a sampling program, so they could bring students down, stand in this area, and then walk down onto these structures and do water sampling or whatever else that they wanted to do. And then planted this in a meadow, not a lot of lawn except for up at the street. Had that little grass verge and our cues to care. And then we had our messier ecology and habitat happening beyond that, but then had well-defined paths with the grass verges on those. So we didn't have to have an English landscape with grass down to the edge. We could have this kind of hybrid landscape that appeals to many of the visual preferences that folks have. So as far as thinking about the order of these things, that's just an example of what you could do. But when we think more holistically about these, we want to think about the variety of practices or stormwater control measures, SCMs, stormwater control measures that we could use. So here's a model that we came up with, and it's in the book here. But basically the idea is as rainfall comes out of the sky, it has a couple of different paths that it could take. So it could go into a landscaped area, it could go into a conventional roof. One tweak on that would be that you could collect that water through water harvesting, or rainfall could come down onto a vegetated roof, commonly called green roofs. And there's some benefits with that. You don't want to harvest water from a green roof though. So you want to keep those functions separate. Or water could come down onto a porous surface, or if it comes down onto an impermeable surface, then we could do things like carve off the most contaminated part that is at the front end of the storm through a flow splitter. And then we direct that first flush, the stuff that has more constituents in it, to treatment practices. And those treatment practices either help filter the water and pull out some of the sediment or some of the soluble or some of the solids that we have, or that could go into things like stormwater wetlands that help actually transform some of the nutrients that we're concerned about that get into our estuaries and cause all sorts of havoc there. So this is an idealized flow model. So you could have water hit the impermeable surface, hits the flow splitter, we carve off the stuff we want to treat, and then we try to keep that water on the ground surface through bioswales, pull it into bioretention, or sometimes called rain gardens. And then that can leave, any kind of excess can leave through another turf reinforced mat swale, go into a stormwater wetland. And the bioretention is more like a leaky pool that drains pretty quickly. So by the time the next rainstorm comes, we're ready to fill it back up. The stormwater wetland is a pool that, or a pond that always has water in it, but it has a little bit of freeboard. So water can stack up and then be slowly drawn down, and then we could get the treatment benefit from that. Then once we discharge from that, we can go into a level spreader, which takes that moderate amount of flow and spreads it out on the landscape as it goes into a riparian zone. So we can avoid what I showed you in the first page of the Grand Canyon tourism promotional thing where Dr. Shelton's standing there. You can see the magnitude of the Grand Canyon. So we want to avoid that, keep the water very diffuse before it goes back into our water systems. So what are some of these things? Here's a water harvesting device. This one I think is still called Fat Boy, but instead of having a round cistern or a buried cistern, this one is nice for urban areas because it can be mounted vertically. It can be interconnected to other ones and holds a good bit of water. Water runs off the roof, goes into a filtration area, fills up the cistern, and instead of stockpiling and holding that water, we want to drain it out so that the next storm comes, we can drain it out. We just want to release it at a slower rate so we can mimic the pre-development hydrology. You might say, hey, that's great, I got a rain garden. Well, that's an excellent start, but here's an 800 gallon or so rain barrel, if you will. Here's a rain barrel that's actually sized to treat the 1.8 inch rain event off of this roof, which is a rain event that corresponds to collecting the greatest number of storms. So we want to collect all that water, save it for no more than 3.5 days and release it, which is kind of counterintuitive when we're thinking about harvesting water. We want to reuse that. You can reuse it for potable and non-potable uses depending on what you run it through. Here's another stormwater control measure. I've got some of my students testing out. Here they're walking on some paving. We've had fire trucks pull onto this. It doesn't break up. It's fine. The pavers are concrete pavers, but the corners are nipped out so that water can easily run off and go into what we call little chimneys. And then the water can infiltrate down into that. So you can have your parking lot and you can have infiltration, and then you can create a really thick gravel layer at the bottom and do a lot of your stormwater detention that's often required as well. So you can have a lot of benefits from that. Here are some opportunities for the vegetated roofs. You can see we actually built this one on a sloped roof. There's restraining systems so that you can actually put your vegetated roofs on sloped roofs, or you can put them on flat roofs. So those are some opportunities. And in this one, the vegetated roof flows through the gutter into a rain garden that's at the base of the building. And we can do that because the building's slab on grade. There's no foundation that water can get into. Here's a bioretention area. Water either sheet flows across the parking lot and goes across our grass verge, which we discussed as a nice visual preference element. And that's our cues to care, that we're taking care of the landscape, as well as the planting design that shows groups of native plants. And we also have water coming from off the other part of the watershed, going into a forebay area and then ponding in here. And then we get a shallow leaky pond for no more than about 10 hours or so. So no worries about mosquitoes or anything. That water infiltrates down through about 4 feet of media and then goes out through a drain into a series of stormwater wetlands. So here's a stormwater wetland pocket. You can actually put these high on the landscape. This is an opportunity where we just had a little bit of space, brought in a track hoe and a little bobcat, just pieces of earthwork equipment, and then actually just tracked back and forth until we got a nice clay compacted layer, and then put some topsoil on top of that, and then planted with wetland plants. And this thing rarely goes dry. And actually, there's a study from Charles Apperson that shows that this is a mosquito reduction opportunity, because a lot of the mosquito predators hang out as long as you keep it in a herbaceous vegetative state. So there are concerns about mosquitoes, particularly with what they carry, but here's an effort to actually help reduce some of the mosquito populations. Well, this comes back to, well, doesn't that look messy? Doesn't look messy during the late summer? Shouldn't we go in and cut all that down? Well, you could, but then you'd be losing some of the additional benefits that this might provide for nesting or some other critters that still might be foraging in this area. So here you have this idea of a grass verge. It doesn't have to completely encompass it, but here you can have some opportunities to walk up. Visual preference, again, we're kind of standing up in elevation, looking down onto it. We can appreciate that. We're not walking through what some people might consider a snaky area, but there are opportunities to enjoy all the different things that are happening in that area. So I'd be remiss as part of the university if I didn't tell you about some of the research that we have going on for streams. We're very interested in what's called landscape performance, but that's the idea of monitoring a variety of different conditions for the social, for the economic, and the environmental components. And we want to see how those things interact. We want to make sure we can do the best job that we can with our site design, our planting plans, so that people appreciate it. And if they appreciate it, then they'll steward it. And then we're also looking at water resources, so we can understand how through climate change and some other things, some of the water flows are changing around, and then changing how we design our stormwater control measures to be more responsive to that. So let me leave you with a quick bit from Thinking Like a River that Wofford College hosted. And this is called Invisible Tributaries. And this just gets you to think about some of these tributaries that you've heard today. And it's titled, Who Am I? It used to be I emerged through the land surface high in the mountains. I tumbled, fell, and then rolled downhill. I stole watersheds, broke rocks to sand before my last stand. Trees blanketed my route, cooled my waters, and fed the critters. But that has changed. I am sick, my headwaters altered, culverts placed and parking lots constructed over top, trash and carcasses dumped, sewage drained. Will I get better? Now come the folks to assess and diagnose, to tell me about me, whether I am okay. The philosopher to ponder why there is water, the biologist to squeeze my fish and collect my bugs, the ecologist to model my inputs and outputs, even my hopper rig, the botanist to classify my vegetative cover, the fluvial geomorphologist to chart my riffles, glides, and pools, the hydrologist to measure my flow. Uh-oh, here comes the engineer. Who makes sure all these folks works together so I can get better? Don't they know without my headwaters, my capillaries, I cannot be? Are these capillaries too small and unassuming to be considered important? Will they be rediscovered and reconnected to me? I want to flow, to pulse with the seasons, to expand when it rains, to shrivel when it dies. I want to be healthy again. Thank you for your time, and I'm glad to take any questions.
Thank you. I think that was a great way to finish this presentation.
Welcome.
Is there any questions? Are there any questions specific for Dr. Calabria? Well, I see a few questions. Okay, so all right, so there's a specific question for Dr. Calabria on the Q&A. And this person is wondering if might address these several questions via email with you.
Sure. Yeah, I'm glad to correspond. If
You can type your email in the chat.
answer live, is that the?
Mm-hmm.
Whoops.
Yeah, perfect. Thank you.
Yep.
And there were some previous questions from previous speakers. How can we, and this is for Jason, Dr. Jason Gordon, how can I access the Canopy program?
That is in the document that I showed. If you go to the Warnell website and then publications and just do a search for Canvas, you'll find the link there. And it is also, I'm sorry, I just saw that question. You can go ahead and keep answering questions. I'll type it into the answer.
Thank you. Yeah. All right. And there's another question. I think this one was for Dr. Elizabeth McCarty. I've heard nesting boxes focus predators. Oh, sorry, you're muted, Dr. McCarty.
Okay. So bees are not the only things that will live in nesting boxes. And there have been some studies that show, yes, that they can attract predators as well. So a nesting box is not a one-time structure. You don't put it out and leave it for 5 years. It's a structure that requires some maintenance. So a nesting box will last for about 2 years, and then you need to remove them. So you want to let the previous generation emerge from it, but seal up the holes so that nothing new colonizes it. Because over time you can get pathogens in those nesting boxes, so you don't want to sit it out forever. So do some maintenance. So like this spring, I'll pull my nesting boxes. I'm going to seal up the holes that are open still, so nothing puts new holes. I'll let things emerge, and then I'll chunk it. And so I do that once every year or two. But yes, you could get predators in it. You'll also get like little roaches if you have some of those mixed substrate boxes. So yes, they can have them, but they also do provide a habitat for pollinators that would not otherwise be there if you don't do anything else to augment your system. Also, I saw a comment about, so there's a couple comments. I saw one about invasive plants, and I put in the chat the top invasive plants from the Georgia Forestry Commission. So there's a link to that right now if you want to look at it. And I'll just quickly read out Chinese privet, brown top, China berry, Lespedeza, kudzu, Chinese tallow tree, Japanese climbing fern, non-native olives, English ivy, mimosa, trifoliate orange, and wisteria. Those are going to be the top invasive plants. And there's one for pruning back plants. If it is not a problem with your HOA, if there's herbaceous plants that die back in the winter, I just leave them out there, and then I prune them to about, a foot and a half, about this time of year. I'll go out and start pruning them probably next weekend. But if that's not possible to leave it out there and let it be brown, then just cut it back to about a foot or a foot and a half instead of cutting it all the way back.
Along with the top invasives question, I also saw that there's a question about the permeability percentage in Atlanta. If any of you know that information.
Yeah, it's highly variable. There's actually a map that's 30 meters by 30 meters, and it has imperviousness for every single 30 meter square grid. So that's called NLCD, and there's an impervious layer. So you'd have to look at your watershed and some other things, but that characterizes what the imperviousness is. So there's public information out there, and then you can also look at aerials and do some takeoffs and estimates as well.
And another question is, so you teach, so all of these speakers are professors at UGA, but I guess the question is, if you're, and I guess this is more for Dr. Calabria, do you practice landscape architect for larger public projects?
Yeah, we have quite a few graduates out there, so I might defer to some other landscape architects if you have some specific consulting needs. But if there's larger projects, watershed type scale projects, and then some public projects, I'd be interested in helping if there's any technical advice or anything like that. I certainly don't want to compete with all the fine students and fine alumni that we have out in the alumni. Our alumni network is vast, and we appreciate them very much. So anything I can do to help projects along, or there's some very specific monitoring and some other things we can do for landscape performance, I'd be all ears. So just email me at that address. So, thank you.
Well, I definitely want to thank you all for your time. We've been working on putting together this event for a few months now. So thank you for spending some time with us. We'll definitely learn from you. And we hope that in the future we can collaborate on some other projects. We can, maybe at a time when we can actually be together in a room, you can come and speak to our community as well.
Michelle, thank you very much for inviting us. And I will say that we had originally planned this. We started talking about this last year, and we had wanted to, at the very beginning, we had thought that we would do some hands-on. And for example, John Calabria could show you in real time what, examples of all these things and so forth. So hopefully we will be able to do that at some point in the future. We'll keep our fingers crossed, because that would certainly add a lot to this workshop.
Yes. Well, I don't see any other questions, but thank you so much for your time, and I hope you have a great week.
Yeah, everybody have a great weekend.
Thank you so much. Thank you, Michelle.
Thank you. Have a good weekend.